was in FOSDEM. It was 20 minutes, a long time ago. This year it was 30-something minutes. So. But do you remember the day that it flooded, the room flooded? One more minute, then we'll get started. Yeah, last call for the MySQL room. Hopefully this isn't too loud, right? Okay. I guess the hallway got quiet, so we can get started. All right. Welcome, everyone. Today, we're going to talk about boosting MySQL with vector search. So MySQL, get into the vector, some of the vector. Today's agenda will be vector-related searches and vector fundamentals. We're just going to overview what are the components or parts that are needed to assemble a vector search in MySQL. First of all, let's get connected. If you're not connected, please, you can scan or find me on LinkedIn. And my name is Alkan. I am working for Altinity as Director of Services. And we focus on ClickHouse services and support. Also, we do have a database as a service as a managed ClickHouse implementation. Previously, I worked at Chista, PlanetScale, Percona, and Python as DBA manager, technical lead, and focusing on MySQL ecosystem. In my earlier life, I was an enterprise DBA, and I worked on Informix, DB2, and Oracle systems, including SQL Server implementations in large scale. And I am known in the MySQL world as one of the most influential database in the community, and I've also co-authored 2 books. One of them is a MySQL cookbook. The other one is a design and modeling for Postgres and MySQL, which I have a copy of over here to gift it at the end of this talk. We'll decide who gets the book. Usually, I would like to give it the youngest in the room, but I've realized people don't want to reveal their age. So that might change. We can change it to maybe the best question, and I'll sign it for anyone. And the other book is the MySQL Cookbook, which has a lot of recipes for MySQL solutions. And other than that, I'm part of the MySQL Rockstar Legends community, and we do have really great activities around the world about MySQL. And I also do SCaLE outside of the work, and that's something I really enjoy doing. And for that, I have a trivia question. And today's question is going to be, what is the name of the horizontal spar that extends from the mass control the angle of the sail? What's that? Boom, he's got it. So he's done some sailing before. Okay, and another question, then, since you have done a sailing before, what is the speed of that sailboat? Guess. By the way, that's my sailboat, and this is how I sail. And interestingly, it can go faster than its own engine under a sail. So that's 20 would be like flying. So it's around 8 nautical miles. So it's nautical miles is faster than regular miles. So it's kind of a thing. Again, the book is over here. So we have the mast and the boom is here. That was a question. So I like to ask some of these questions because it helps people to relax, including myself. So, okay, let's go back to the vectors and dimensions. Today, in the world of AI and machine learning that you actually hear almost every day with the OpenAI and ChatGPT in our life, there's a concept called vectors and dimensions. So those are the data points that we have and we actually store them in the database, and so we can get query out. What happens is, in our databases, we already have the data, but we just need to map them to vectors and dimensions to get meaningful results from that. But before that, these are the objects, and they actually represented, we learned in our earlier studies, 2 dimensions, 3 dimensions, and now to represent an object, we need higher dimensions. The higher the dimensions are, the accuracy will increase. But from that point on, your compute and memory requirements will increase to get to that. That's why the GPUs are very important for the AI workloads, and that's how we can get actually to these data points faster. So when the dimensions increase, it will help us to have a more meaningful information on the data points that we have than before. The higher the dimensions, better the data. So how do we represent them in the database? Before getting those dimensions into the database, we need embeddings. So basically, embeddings is the algorithms that takes those dimensions into data points, which are actually represented as decimals and integers. And then we load them into the database so we can actually run the query that we want. Again, those are mathematical representations, and then they actually capture the semantic meanings, so we can do the data analysis. Okay, hopefully everyone has some sort of a visual understanding of that. But before the visualization, so those data vectors transforming into the data points, we actually have to get them into the database. How do we do that? On this image, we have the OpenAI vector embeddings for the Wikipedia article. So what OpenAI did is actually trained all the public data sources, starting from Wikipedia and others available out there. How they do is they take the text, convert them into an embedding, and then those become a vector. With the vector dimension was 1536, and then they stored it. So when we actually go into ChatGPT and type a question, it goes out using this data is stored, and then does a search that I'm going to represent over here. In the meantime, while OpenAI was kind of trying to do that, all of a sudden, one morning we woke up and then there was a DeepSeek, and DeepSeek was able to do the similar embedding with much more dimensions, almost double the size of the dimensions, with the same data set. So what that means is they got to this point of embeddings generated 100x faster than OpenAI all of a sudden. And this is actually, they can actually support up to 8,000 dimensions, which is much more accurate than originally that we actually thought it's really great. So I always say that this is only baby steps. This is only the beginning of everything, and this is gonna just grow. Maybe these numbers eventually become like a much larger and bigger to represent much accurate data. By the way, this information is almost daily changing, and we are actually in the really growth area. This was like February, so we're in March, and maybe next month something else will come with a different model which can actually process much higher dimensions. Okay. So why do we need the vector search? So basically it's a efficiency, and the AI-based applications needs to create a search that actually gives a meaningful information. And sometimes if we don't give you probably all have experienced the same thing I did, is if you don't give the facts that what you're thinking to your query, you get something else, which may sometimes not meaningful or not relevant to what you're looking for. And then you have to ask the question again while it's learning, and then it gets. That's why the vector search is very important, to get the right data ingested, and then the right data is mapped. So we all know that it's actually helping the AI and machine learning applications. And what happened over here? Okay. Let's go back in time. roll back the tape a little bit. How did we do this before the vectors? A text search. So we kept this data in the database, and then we did a text search. And the MySQL or all other OLTP data stores wasn't very efficient doing that. And that's why there were some other technologies born. I've used Solr, Sphinx to index those text fields, and then our searches on whether it's on e-commerce site or some other application, it would use that search maybe on a replica, and then get that meaningful data out, which would map to a product or product ID, and then you would actually have your application or business logic working. So that was the traditional method. Now we're not on that traditional method anymore, because we can actually generate much larger dimension embeddings, and then we can load them into the database and then do a query even more meaningful. So that's why it's vector support helps to solve a very major problem in the OLTP world. Why I say in the OLTP world is because there are some, we'll talk about that, there are some other solutions that will be dedicated to do that type of searches, but you need to invest into that from a time and material point of view. So let's go back to our subject, why the vector search is important in MySQL. Because we run MySQL workloads at scale and MySQL workloads at production. With the production data, it's already there. MySQL is still the world's #1 database at scale in the OLTP-wise and the open source perspective. And this will improve the existing MySQL databases text-based or object-based searches significantly. So that's why we think the MyVector will help come in help to solve that problem. Currently, MySQL doesn't have an extension or a solution in the open source version. There is a solution called HeatWave that can only be run in the cloud, and it uses a similar technology, not the same, to solve this problem, but you cannot run it on your existing local or on-prem database. It has to be in the cloud, and you have to do it by the. So let's take a look at the use cases again. So natural language processing is one of them, and recommendation system is one of them that I could think the top 2 ones are going to be relevant. And I tried to do a demo on this coming up. So in short, it's actually a similarity search. You have the data points, and you have the data, and then you try to match the closest data to it. You can do a point select, or you can do exact matches, depending on the scenario. But for larger data sets, it doesn't scale. So for the really large data sets or large dimension data that we're going to demo over here, you would need something like this. And the other thing is the image recognition systems that actually really using this. I think it's not new, but it wasn't available for us to use, from a database point of view. Okay, let's do this comparison over here real quick. Is that there are vector database providers in the market. So don't take it that we don't have any other solution in the world that can actually act like a vector data store and then solve this problem. And some of them are listed over here. I'm nowhere expert in any of these databases, but they are made for this purpose. So you still need to do some sort of a coordination and integration, maybe some sort of an implementation into your business or ecosystem to map with the rest of the data that you have, because these are vector database providers. They don't do OLTP, so you can't run transactions on them. You can't run, financial systems. You can't run healthcare systems. You can't run, but you can analyze the data that you have. So that's the thing. So whereas the vector store providers are also listed over here, some of them are made for analytics workload, which they scale really well. One of them is ClickHouse. I also focus on this technology because it's open source. Elasticsearch, Single Store, TypeSense, some of them others. And then we also have the OLTP data store that has an extension. So some of them are with MyVector, it's MySQL. MariaDB has a vector search ability. Postgres has an extension, and TiDB has also released vector search capability. And I see this literally almost every day from other database providers, including cloud providers, adding these features as an option or add on them to existing services. So it's there. And so we have the user application and the embeddings, and then we actually have the vector search. So this is the workflow. So we actually use the same methodology, and whether it's a database provider or a vector data store, you would use the same thing. But in our case, for vector store in MySQL, you already have the other transactional workloads that you can map within the business over here. Okay. So if we compare the vector database versus the traditional databases in OLTP, we have the database schema tables, and then we keep them as rows. In ClickHouse cases, we keep them as a column store. There are other column stores in the world. And then we actually query. We do an exact match or try to get the exact closest match to the query, and then we return the columns that we need. And that will serve our business logic in the sense of whether it's an ID, maybe a meta, maybe a reference table, and ID description, and then you search, and then you get back the data. But whereas in the vector space, we have the slightly different operation. We actually have the data types is basically vectors and dimensions. And on top of that, we have, I'm going to give some examples. On top of that, we have some indexing over it, and we have some processing that is done on within the same ecosystem where we can actually use these on side by side. For MyVector, we can actually have combination of MySQL's InnoDB architecture with the OLTP data store embedded with the, or paired with the vector search over here, without having to go out to the world and implement these, where these don't talk to each other. You need to programmatically talk to any of the databases if you have one of these database providers, which they come with many libraries, software development kits. I've taken one of them as a class to see how it works. You need like a bunch of Python code. A lot of libraries needs to be imported, and then you can basically generate embeddings and process data, but none of that talks to any of the databases over here. You still have to do some DIY over there. Okay. So let's review one more time over here. So we have, why is this? Okay. We have some unstructured data that could be image, video. For example, video processing is even much more higher dimension than anything else. So we will focus on the text one for now, because text, image, video, it goes like that. So you have video for the unstructured data is much more processing power is needed to get that, because you have the frame rates and you have the video, the length of the video, and the resolution of the video to basically encode that into meaningful data set within the database is going to require a lot of processing power. But anyway, that's unstructured data, and then we have AI encoding. So of course, there are some standards for it. So we don't actually come up with our own. There are some standards that the open source community is using, and then we convert them into a structured data, which will have an example of a vector data store in the database, and then we index, and then we can actually have a vector search. Okay. So let's take a look at how the MySQL plugin architecture works. So user-defined functions. We actually have these user-defined functions in MySQL, did not exist at the time of this was implemented. And Oracle MySQL open source has started implementing vector search within the MySQL, released it in version 9x. And there are some functions available in the newer versions. And then for var binary in the MySQL, we use, because there's no data type as vector in MySQL 8x, and it is released on 9. There's a vector data type. So basically vector, in parentheses, the dimensions, and that it can handle. So MyVector integrates similarity search via HNS indexing. This is another concept, and this is another thing. Maybe we can talk about it if we have time. And then we do a similarity search, and then there's a nice syntax for it, and then it's completely managed by stored procedures. Okay, that's the architecture. Right now, the plugin needs to be on a build. Basically, you have to compile MySQL in order to get this one into it until we have Docker images ready. This all in the GitHub repo, open source. You can go in there, do these steps and git clone. But it requires a little bit of a knowledge on how to compile MySQL. It's not that difficult. Oracle MySQL has a very nice documentation how to compile it. You can basically download and then compile, and then you can install it. So this enables the MyVector plugin into MySQL. This is how it works. So say we have downloaded the source code of MySQL, compiled it with the MyVector, and then we actually added the stored procedures and the user-defined functions in it. How does it work? The way that it works is there are two modes in it. Okay, let's take a look at this one first. So we mentioned version 8 as a InnoDB and a plugin and a var binary data type. And then on the version 9, we can have an InnoDB plugin. So we don't actually touch anything in InnoDB. It still continues. So you can actually continue using your OLTP as InnoDB. But in the sense of adding the MyVector, you actually have to get it on compiled and installed. So once you do that, we have two modes in how it works. There's a batch mode and there's an online mode. The batch mode is basically we load, we're going to have a demo on this one, and then build the vector index on it, and then we can start using it. But once you do that, it gets you to a point that you can actually have the index maintained by the binary logs. And then you can also do the online mode where you actually load the index and then read the index, existing index, and then you can run the vector search. How that works is visually over here. If you think about it, you have the index built. You can actually reuse that index that is already ran. Because indexing is also a costly operation. In generally, even in InnoDB, it's a costly operation to create the initial index, and then we maintain the index as the data points change. In this case, you do a batch mode, you build the index on it, and then you can actually keep track of the changes using the binary log. So, okay, HNSW index is something that is hierarchical. What is that? Yes, navigable small world. Thank you. Index. This is a common index that is used in this type of searches. And of course, there's a mathematical representation of how it's done. There's some sort of a logic behind it. It's not the traditional, the indexing that we have, whether it's on B3 indexing or for the column stores, LSM or merge tree engine indexing. This is a slightly different than that. We're not going to get into that, but basically, this index is the most suitable method for this type of search. And it's proven that it is crash safe, and it can actually really work well with the MySQL ecosystem over here. Okay. So I put in some examples over here just to see. We're going to do this together, but we create a table, and then we actually, once the MyVector is installed, we actually defined the vector field using some annotations, and then we say, okay, this is HNSW, and the dimension is 50. This is the words example on here, and then you have the size, and then you basically call this sort procedure to build the index. This is how it will work. And then there's some more examples over here, and okay, this was 8x. I wanted to kind of highlight over here between 8 and 9 is because in 9 we have the vector data type as a vector, so we can use that data size. So if it's a version 8, we still have to use varchar, but in version 9, we can use the vector data type. Well, is there a difference between the data types that the vector data type? From a performance standpoint, no. But because it's a different version, it's not apple-to-apple comparison. So it would be okay to test on 8x, for example, MySQL version 8 is there, and then we have vector data type. We could have compared the differences, but now it's kind of not okay. So there are some other examples over here, and then we can actually construct function actually converts the embeddings into a human readable format, and then we can actually display. And there are some examples over here to call these functions for the distance. So this is the most important thing, is the distance. Oracle has a distance function also. So the similarity search works by a distance, and the closer if it's 0, you're at the point. If it's further away, you will have an integer showing that it's further away. And that's how the similarity search works. Okay. So this example on the AND search, approximate nearest neighbor, is you can actually select, and then this will display the approximate nearest neighbor for that search, for that query. Okay, maybe there are some other stored procedures over here. Building an index is a stored procedure. The status of that index is another one, and then we can open and load the existing index, and then we can drop the index. So these are how we maintain the index that we built for the data set that we have. From an administration standpoint, if you have to do this, of course, you can basically automate some of this depending on the data that's coming in, and use these functions, stored procedures to maintain that index. I didn't want to get into benchmarking, which I didn't on my last one, but I think we got a lot of questions on how this works. From the weeds of it, MyVector actually performs really well compared to other ones in the option. But in MySQL, since there is no vector architecture built in, we can only assess how it performs compared to pgvector and MariaDB right now. The other one would be comparing against TiDB, I guess the closest one in the market for the vector search, and it really handled well. These are preliminary results, and I'm not don't have all the facts over here to discuss or time. Maybe a separate talk could be good for the benchmarking. In short, for the multi-threaded architecture with the higher CPU machines, the building indexes can be faster, but single-threaded compilations of MySQL, it's going to be longer to build indexes. And after you build indexes, depending on the data points changing, it will also require you to maybe rebuild the index or maintain the index well to get a better performance. So I can say that. And then we have some numbers over here comparing against the MariaDB. MariaDB had some modified version of HNSW indexing. We've seen that. So that helped them perform well. And pgvector is same. It's using HNSW indexing, and it's performing well compared against those two solutions. But again, that's not a point too much over here. The point is you already have a MySQL, you're already running in production, you already have the data. This is an option to use vector search using HNSW indexing methodology. And the demo. Okay, everything else is in this. Before the demo, do we have any questions? No. The question is, does it know we need to rebuild the indexes? The answer is no. It's manual process right now. and you kind of need to kind of maintain that. But as I said, it's going to require for you to monitor how much data is changing, how much you're actually maintaining, and if your searches are going off the hook, that means you need to rebuild it. And that's really not that difficult to add some logic, because if you're getting further away from your searches, and long time ago, I ran an e-commerce site on MySQL, and it would crash the site if you search for an adapter, because adapter is a very generic word. So it will find a lot of, I mean, if you say a laptop adapter, then it'll find a close. Say an adapter could be anything. It's a very generic word. You know, it could be a USB adapter, or it could be a power supply adapter, some sort of an adapter, or it could be some hardware adapter. That's why you have to kind of understand your search criteria, your search patterns, and then basically build upon that. But with this new technology, I think it'll be much easier to get to that point, because you're basically moving further away if the index is off over here. Okay. All right. So we have a Stanford NLP data set with a 50 dimension and a 400K data points on words. So there are some public data sets that we can test. Interestingly, maybe it's not a surprise, this OpenAI already trained on these. So if you actually go out and make a search, they already, because it's a public and open to the search. And I want to kind of demonstrate that over here. Okay. So this is the words database, and then we connect to the database. In our case, our version of MySQL is 9.1, source distribution compiled, and then we actually have the vector columns is a part of the plugin, and then you can see the vector table that is built over here with the dimensions and the annotations over here on the information. So we have a couple of SQL statements. This is part of the demo in the GitHub, so you can basically go out there and see. We have the words 50 dimension table. Okay, so we have the word ID and a word, which is the text field, and then we actually create the MyVector data type with word vector. And then we create that table. So this table is created, and then word vector becomes MyVector column with the HNSW index with 50 dimensions, and a 400K is the size of the index. And again, basically, this is the same table as we would have InnoDB engine, but this is outside of the InnoDB, so it doesn't actually have anything to do with InnoDB. So let's take a look at what the data point looks like. It's basically the data is when it's encoded into a table. These are the dimensions and the data points. So this is not human readable, anything to do it. But when you have the embedding, this is what it turns down to. So we load this data into MySQL. And then we count the number of rows that we've inserted for this table, 400K. And so vector to string, for example, on version 9, it's a MySQL Oracle function, so it already exists. So if you actually have a data point that is there, you can actually do this and select that. So it'll turn into a string. The difference between that and MyVector is this is a scientific representation. This is a non-scientific decimal representation of the data. So if you do the MyVector search for the same data set, and you'll see a different representation. It doesn't actually make much difference between them, but I want to show the difference over here because they're not human readable. Basically, you will see over here, if we have the searching for a book from this data set, and then we're comparing against a paper over here. So the distance between the book and a paper is 17.6. And another example over here, book and the novel is 8.1. This is how the similarity search works. And if we say book and a car, we're going further away. So this is where ChatGPT gets a little bit some wrong answers at the time because you have no actually correlation with the previous one. And then we actually have another question over here. With a book and a library, you will have something relatively closer than a car. That's what I wanted to show over here. Okay. So if we actually do a search, similarity search between book and the rest of the data that we have, and you'll see relevantly book is 0 is the closest point for that data set. So this is ordered by distance. And that's where when you're actually shopping around Amazon, and then you'll see underneath there's some, okay, these are the things you should look. This is how the same concept over there. And because you search for something, you're looking for an item, and its relevant search is done by something similar to this. So on this data set, we built an index, and this is where the workflow was. Index is created, and it's saved in a binary log, so that we're keeping track of the changes. If we have actually additional data, it's in the binary log. We can always go back. So in the search examples, we're going to do a search for Harvard, and let's see what the correlations between this in this data set. So we search for the universities, and you'll say Harvard, Yale, and Princeton, and you can see for the MyVector construct, it returns this data set. So we select on the closest to Harvard. If we search on that, it'll find the 0. And then the other ones closest to Harvard, it knows that Yale, Princeton, and it goes like that. So it's pretty cool, actually. So that was the example, demo 1. I have 2 more demos. Do we have time? Okay. Yeah, I think we have time to do one more. Okay. So this one is going to be Wikipedia's OpenAI Dpedia vectors table. So this is a Wikipedia example. The other one was a Stanford NLP dataset. This is a Wikipedia dataset that was generated and converted into a data points. So, okay, so we have Dpedia table. Okay. So this has 2 tables. One of them is for the reference, like I mentioned earlier. You have the ID, article ID, and the title for that. And then for each ID, you have the vector, Dpedia vectors are embedded within the database. And this one is 1,536 dimensions, which is nice. And then with 6 kilobytes in each vector store. So we have 1 million records in this table. And relatively, those IDs are matching with the Dpedia vectors table is a 1 million also. So you have, and we build an index over here. So this one is pretty fast because it's a multi-threaded index build. And also this is a 48 vCPU, pretty OVH machine. It's pretty powerful. It's not like your a small spot instance EC2, so it's a powerful machine because we're seeing the benchmarks are done on very strong machines in comparison. So I think this made sense. So okay, we have a little bit of a DIY over here, a small Python program that we're going to test over here. So within OpenAI embedding, we can actually ask a question, and using OpenAI, we can generate the embedding. Using that embedding, we do matching. Okay, this is what the demo is. And the question is over here, tell me some famous ancient structures from that data set that came from Wikipedia. And then we convert that into an SQL, because that will convert this embedding, this text into an embedding, and that will generate our SQL statement. And this is a sample query over here from the Wikipedia database. So we actually run that in MySQL, and then this gave us the answer for those top 10 questions for the ancient structures. Okay. Of course, the pyramids, monuments, and some of the other stuff. Okay, another example over here is we are changing the question. It's just like a line, some good marketing strategies. This again, public data set from Wikipedia using OpenAI embedding, and we generate that embedding, and then we parse it to our server, and then we actually get that query ran on MySQL, and then we get these articles. With the article ID, there's a good marketing strategies that you can study. Okay. We're not going to get into the brute force. That's a different subject. We can also do that before we run out of time. I want to have a little bit of a fun over here with another demo, because we had a question. This is all like manual stuff, and you run that. And then is there a RAG solution, like when you actually ask a question to the database, and then you get something more meaningful other than just the query results? Because we could get, okay, ancient structures, the marketing strategies and everything else, but that doesn't tell me today's AI solution. So we're going to do something a little bit further on that. How can we drive this using the same data set or similar data sets with a similar methodology? So we have another data set. Well, it's at the Wikipedia again, but we're going to run something else over here. Okay, this is the clinical trials. Okay, don't worry about no personal information, HIPAA compliant, nothing. It's again clinical trials made on public data. It's for open source for studies, some of the Stanford papers. So we're going to do some fun over here with that. So clinical trials online is our table. And then we have, again, HNSW indexing with 768 dimensions. It's 1 million records. So we do a point select on this ID, just to randomly show effects of exercise program, children, and all that. There's some clinical study that's made off of, and it's in this data set. So that's kind of an example of how that. So we're going to kind of parse this data. And then if you do a vector to string, this is how it looks like. Not human readable, as usual. I don't know if it's fun to see that, but we just need to kind of compare that and show it. And okay, clinical trials online, we have 283,606 records for this data set. We build an index on it, and index status function shows that we have the index and number of rows. And okay, so we have this sentence transformer. What we will do over here is basically get that data set on the clinical trials and ask a question. Say, return physical activity after knee surgery. So the idea over here is to get from that data set, from our question over here, which is the returning physical activity after knee surgery, get a meaningful answer, other than just number of rows. Okay. So we run this, and then we get what happens is you search for the 10 results within the database, and then you actually parse that into the OpenAI, and then you get the answer from what this, meaningful answer is. So it will summarize 10 search results from the MySQL, and then I'll ask that question with that, and then it'll give you the answer for the several studies are being conducted, and studies focus on impact on exercise programs. So our next question over here, return to physical activity after a knee surgery. And then basically you can get similar results off of this in the... Okay. So you will have the 10 search results, and then the studies focusing on exercise, and this is the answer for that question. And there's also, you can see the raw results, which is basically the embeddings and everything else, which is in the GitHub right now. And this concludes the demos, and I can take some questions after this. Yes. Mm-hmm. Mm-hmm. Yes, we can actually do from the status monitoring, basically, and then you can see how many rows actually within that index, knowing the source data. If it's indexed, then it'll have the same number of rows, and then we can actually do that. But in general, is to complete the indexing as fast as possible so that the processing always continues. That was a good question. Thank you for that. Any other questions? Okay, the question is, does it make sense to test it on 8 or 9? So as far as I know, the production workloads are still on 8. 8.4 has come, and there's the 9 is an innovation release. I think 8 is the best option to run it in production if you already have it in production. And I would recommend to compile and run this, and then attach it as a replica, and then use the data set that you need in that replica and run that workload within that replica. So that's the method of using it. 8.4 is relatively new. I think it's possible to do it on 8.4 too. For the 9, the innovation release, you can have some Oracle functions also that are already built in, depending on the scenario, but this MyVector functions covers all the Oracle functions that already exist today. Any other questions? Well, thank you. Before that, I think I'm going to give this book to him. What was your name? Eric. Thanks for the nice questions. I'll sign it after the session, okay? All right.
Hello?
Hello? Can y'all hear me? More? All right. All right. So today we're working with Vital Source Technologies. So I've been about 10 years now. When I first started, we had 2 databases. We had one in production, one not in prod, and that's all we had. Now we have closer to 500 databases, and I would like to say the team size is identical now what it was 10 years ago. Not been given any more people, so we had to do a lot more, obviously, with a lot fewer people. So like I said, I'm the director of systems engineering technology. My absolute about my job is I work with and the people that I work for. I was raised by a single mom, and I feel like that's who I'm working for, working at this ed tech company. We do a lot of really good work. I've also authored a young adult book, and I'm a mom, which is one of my absolute favorite.
Morning, everyone. Thanks for coming to our talk today. I'm Alan, worn a few hats in tech, everything from leadership, engineering, systems, data, and software. Also enjoy writing. Thank you. First off, these slides will be shared, and if you have any questions, just raise your hands as we're going, and we'll get to as many of them as possible. Worst case, if we're thinking we're getting tight on time, we'll push some of the questions to the end and see what we can do at the end. And of course, you can always poke us afterwards. We'll start by covering some concepts you may already know, but it'll help set a basic foundation for the rest of the talk. Then we'll discuss what CattleSpa is, and we'll walk you through the project's timeline. Together, we'll go through a single patch workflow example so you can see what that looks like, get an idea of how it works. And at the end, of course, we'll wrap up with final thoughts. So let's look at self-healing and what that means. If you look up the definition in the Cloud Native Glossary, you'll get these 3 activities. Thank you. Recovers from failure without human intervention, compares actual state to desired state, and does what is necessary to accomplish the desired state. So basically, if the system finds anything that doesn't match the desired state, it takes action to attempt to fix it. We'll be talking more about this, of course, as we go. What do I mean by infrastructure automation? It's using software or scripts to automate managing our cloud systems with the goal to reduce the need for the human engineers to manually manage things. Proper automation combined with good processes will greatly reduce issues and surprises, while also making rollouts and issue recovery a lot easier. Infrastructure as code, or IAC, is provisioning through code instead of manually going through UIs or command line or whatever. We currently use Terraform and Puppet to accomplish this, and of course we commit all of our code to GitHub. Major benefit of that is all the documentation and versioning of our environment.
All right, so everybody who's been in the industry knows naming is hard. We really put a lot of thought into the way that we name our instances. This is an example of what we do for like our databases instances. No, we do not use managed services for our databases. We like to punish ourselves. So the first part here is our project abbreviation. This is used by a lot of things. It's used for our FinOps reporting. It's also used for CattleSpa and some of the other scripts that we run. The second part is either the application or the database. So here you would see, for example, we have a notes application that does notes, highlights, bookmarks. So here it would be VNP notes. The second part is our database. So it tells us it's a database. It tells us it's MySQL instead of Postgres, Mongo, Neo4j. It tells us that it's O1 in that particular cluster. So we might have like multiple notes clusters, for example. So this would be the first cluster. P01, again, it's prod. It's O1. This is just a differentiator between any others that might be in that particular cluster. Replication cluster is what I'm referring to here. And then the last part's got a lot of data in it. It's the region and availability zone. So here, it's US East 1, Bravo is the zone. All right?
Let's talk about runbooks. Before we can create this awesome system, we're going to want some solid runbooks. Our computers tend to do exactly what we tell it to do, of course, for better or for worse. So for us, this makes runbooks an important part of the process. Let's dig in. Why a runbook? Well, we want to clearly define the steps we're going to use for our automation. These can also be used by humans at 3 a.m. when the sky is falling. Good runbooks will improve both the human and CattleSpa mean time to resolution. How quick are we getting it back up and running? We'll use them for incidents, like those pager calls in the middle of the night, as well as regular tasks, especially if those tasks are rarely performed, such as updating DNS records once a year. This means not having to relearn how to do a job that might be needed rarely or even something we do often. It helps set the process. Standardize your format. Figure out what you need on most of your runbooks and make it part of a standard template. Anything else can be a comment or a note on the runbook if you need any other additional details. A standard format is going to make it easier for multiple engineers to create and maintain the runbooks while still keeping a consistent look and feel. Consistency also means the reader will readily understand the purpose and content of each section of the runbook, even one they didn't write. This is important to avoid mistakes caused by misunderstandings. It'll also make following it faster and, of course, easier. Something that could be very important if it's being used, for example, again, to fix an on-call issue in the middle of the night. At the same time, it'll make converting it into code easier if it's clear. Let's have a sample. Here's a sample of what a runbook might look like for a volume that's filling up. Choose a clear and concise title for the runbook. It should be obvious what it's for. Define the trigger condition for what prompted the alert or remediation process for this. Clearly state any important prerequisites, such as perhaps no other alerts at the same time on that resource, that might invalidate this solution or cause any complications. When specifying commands to run, it's important to specify where and how to run them. Is it a Linux shell command? Is it being run as root or sudo? Or is it something like a MySQL CLI command being run from in MySQL? Again, let's avoid the confusion, be clear. Provide steps to verify in the end that it's been resolved, as well as talk about notification strategies, how it's being done and what's being said. So for writing for automation, decide what needs to happen to trigger your runbook. This is probably a metric exceeding a threshold you decided on. Did you get that disk alert? Then before moving forward, you need to verify if there's still a problem. Yes, we're still running out of disk space. Now the runbook moves into the clear remediation steps. No explanations are needed here, no reasoning, no backstory, no novels. Decision trees, however, are great. Remember, you're also writing this for automation. If you feel like you've just got to write that long-winded explanation or the reasoning, link it to the bottom of the runbook as a separate document from somewhere else. Prerequisites. Prerequisites are an important part of an effective runbook. These are the things people might take for granted, such as noticing that there's more than one issue or something else more important going on at the same time with this resource. A lack of defined prerequisites on the runbook is just the kind of thing that's going to get us into trouble, especially with automation. A possible good prerequisite could be verify the trigger is still valid, is the system online, and does the system have any other critical error states outside of the current one that we're looking at now? Let's talk about an example of not considering this. Let's say, for example, we had 2 error conditions on this resource, and the solution for problem A would also fix the issue for problem B. But implementing the recovery steps for problem B might actually cause further problems because problem A also exists. Let's just say, for example, the underlying issue is, I don't know, something was accidentally deleted. And let's say that the solution for one of those problems is to restart the server. But let's say that thing that was deleted is still in memory. So if the solution for the other problem was to restart the server, we've just lost what was in memory. Obviously, your steps need to be clear and concise. Think about if you're reading or writing a story. You don't want the writer to ramble on and get lost in unneeded details. Keep the reader's attention. Make it as easy to understand as possible. Our runbooks follow this thinking. The commands should be complete, precise, and clear, including how and where to run them, as we mentioned earlier. We only want to provide a basic explanation of what we're doing in the runbooks. If you want to provide any deeper explanation, like I said, link it. To be clear, I'm not talking about simplifying the commands or skipping any of the commands, just the explanation of what they're for or how they work especially. So after we've fixed it, hopefully, we're talking about verification and post-recovery. Make sure to include how to verify everything is configured and running the way we expect. Again, clear commands, and consider showing example output of what a good state looks like. In the event the runbook process failed to properly fix everything, consider if we should fail forward instead of completely failing back. Failing forward is where we get the system in a better state than it was in the error state, but it's maybe not perfect the way we really would like it to be. Perhaps it's usable, just not perfect. That buys us time to get it. We weren't able to get it to the fully fixed state in the first place. Maybe we ran out of time, but probably more likely we ran out of time because we weren't quite sure what the real problem was. Getting it to the failed forward state, again, it's better than the critical error state, and it might also mean that when we're ready to do the full fix, that since we're in a partially better state, that it should be faster and easier. hopefully. As I mentioned, with our runbooks, make it as easy as possible for the engineer to code everything up. For whether it's maintenance or an outage to get things fixed. To do that, let's include any helpful observability tools, dashboards, whatever. If needed, provide possible hints for what to look for. Again, sample outputs, things like that, as well as any other things to help with the troubleshooting, such as maybe any queries to run the database, whatever. Anything to help with the troubleshooting. Test your runbooks. Really test everything, right? But we're talking about runbooks here. So where possible, automate the testing of your runbooks. This could be, for example, automation to create the error conditioning. Like maybe we have a script we run, maybe it just filled up one of the disks. So if we've got an automated process to repair it, let's see that runbook process, that system, let's see it go ahead and fix it. If it's not yet automated, then the tester can go through and run the runbook, step through the steps, and make sure everything still fits. When you're done with, as always, especially if you're doing testing or whatever, note any possible ways to improve the process, and of course the associated documentation. We always want to be improving. Personally, as far as documentation, I like Markdown for my documentation notes. It's super easy to version control and it's human readable. Let's recap about the good runbooks real quick. Faster self-healing, clear instructions, reducing chances for errors, automation where possible. Don't forget that fail forward, fail back. And test them, keep them up to date, review them. Let's talk about some of the major pieces of technology we're using in our solution. Here's a quick list of all the main hitters. We're going to be going through these. Sorry. Terraform. For example, Terraform is one of the best tools for provisioning infrastructure. It handles the initial steps of setting up a given resource, such as networking, VMs, disks, and more. After the resource is provisioned, we'll talk later about how we use Puppet to finish installing any applications, packages, and configuring those. We store the state in GCS buckets. It gives us version control and deletion protection. And with declarative configurations, we don't tell it how to do something. Instead, we tell it what we want, specifics of what we want.
Yeah, just to go back to that deletion protection, we actually need that. We had what we call war games or simulated trauma a couple of months ago. And in our thankfully, non-prod environment, we had one of our juniors wipe out the bucket. And when he went to go do a Terraform plan, it said 6,000 plus resources to add. And he was like, I don't know what I did. So thankfully, we were able to roll it back. All right. So on this slide here, just to go over some of the things that we use for our CattleSpa scripting. We also use some of this for FinOps, by the way, our FinOps reporting. So these labels here that you see, I don't have the little doohickey, but these labels here that you see we use in both our CattleSpa scripting and in FinOps. For example, the application that we have, this allows me to tell each application this is how much you're spending in our environment, all right? If I'm decommissioning a resource, like notes, we're probably not going to decom notes, but if we do. If we go through and we decide we're going to get rid of all of notes, this allows me to flag all of those resources to get rid of them, all right? This helps tremendously, and we'll talk about this a little bit more, but this helps tremendously for that unplanned uptime, right? Because I can just automatically get rid of these resources that are labeled in this way. The labels are something that we also review pretty regularly just to make sure that we're not causing any problems. And like Alan said, we add our Terraform to GitHub, so every time there's a change, it's done with a peer review. It doesn't get applied otherwise. And when you're using it for automation, that's extremely important part of the process. Yeah, so like I said, this is what we use for both the FinOps and CattleSpa. All right, and then here's an example of the metadata that we use. This, I really like this part. It's my favorite section of our Terraform. This metadata we use to create the config files for our databases, right? You can see here for our buffer pool, we usually go with a default 65%. We make changes if we need to, but our automation stands it all up at 65% of the RAM. That works for us, especially for a lot of our boxes are not small, they're big. So we don't need more RAM than what we have there. But anyway, so this helps us with our Puppet. This helps with our configs on the instances. And it helps a little bit with the CattleSpa. This bootstrap URL that I have up here, that actually will lay down our Puppet so that Puppetry can come in and run it. It's that first thing that gets ran on the system. I think that's it.
Let's talk about GitHub Atlantis. GitHub Atlantis allows developers to manage Terraform changes through PRs, pull requests. It provides a lot of functionality and features like error detection, audit logs, and so on. Using it eliminates running Terraform plan and Terraform apply locally. On most of these text slides, we're providing the URLs at the bottom. There's a lot to them. I encourage you to check them out. Yeah, almost everything here is open source. Puppetry. Puppetry is a tool designed to manage Puppet manifests effectively. It ensures configurations are managed and distributed securely. It supports managing infrastructure for infrastructure configurations for large-scale infrastructure. It integrates with Git for versioning and change tracking. With it, we can streamline Puppet manifest management, enhance configuration consistency and reliability, and we use it to facilitate CattleSpa for infrastructure management. Puppetry works across cloud platforms, though note, according to the maintainer, it is unlikely to support Windows. HashiCorp Console. This is a big piece of our solution. We use the data in Console in a number of different ways. Having it also allows us to consider a lot of other interesting automation ideas, future brainstorming, that kind of thing. We have highly dynamic environments, especially when we consider we've got multiple engineers, automation, scaling, high availability, all of which could be making changes to the systems and configuration at any given time. For this, we need a reliable single source of truth. Console gives us that. We use it for both services and infrastructure data. Console provides a consistent view of our environment, the services, some aspects of their health status, and crucial configuration details, all across cloud regions. We even use it to automatically update some of our documentation. In our solution, our console is automatically being updated to reflect changes. We then use that data to update, for example, our database quick reference page in Confluence. This page is used by the engineers and any other interested stakeholders to get a quick view of the current databases and their server details. We just happen to call that page, "Dude, where's my database?" It's inspired by a movie, obviously, "Dude, where's my car?" Final note, carefully consider how you design your keys and the directory structure for the keys. You can think about, for example, how you might be filtering those subkeys in your workflows. Changes later will be painful, right? Because you're going to build software around this and then more software and more features. And if later you decide, oh, well, I needed another subfolder, another subdirectory in your console keys, fixing it later means fixing all the referring tools as well. Console templates are awesome. Console keeps an eye on console's key value store. Whenever a key is updated, such as maybe a new primary database node has been promoted, console template will regenerate and push out the relevant config files to wherever they're needed. After generating a new config, console template can also run custom commands to notify or reload services such as Proxy SQL, web servers, or any other application that needs the updated information. Of course, I just lost my spot. This means failovers and scaling events usually don't require manual intervention on our part. The templates can also be versioned in Git, which is nice, enabling collaboration, review, rollbacks. It helps maintain a robust and transparent configuration process for us. By consolidating both infrastructure data and database topology in console, again, you've got that single authoritative data set that every service can reference. This reduces errors and speeds up recoveries after failure. Console templates provide the automation glue that turns our KV data changes into real-time config updates. It's one of the cornerstones for achieving rapid failovers and our self-healing architecture. Proxy SQL. If you don't know about this, if you don't know about any of these tools, I would really check them out. Proxy SQL acts as a gateway between applications and the MySQL databases. Its layer 7 capabilities allow it to inspect queries for more precise routing and load balancing. Tons of functionality. One of the key features in a self-healing architecture is the ability to route writes to the primary and reads to the replica. If, for example, a primary fails, Proxy SQL paired with console can seamlessly shift the writes to the newly promoted primary. One of my favorite features of Proxy SQL is that it allows live configuration changes, reducing the risk for downtime and ensuring smooth failovers. This is critical in a fast-moving automated environment. By leveraging console's KV value store for real-time updates on, say, for example, which node is the primary, which ones are healthy, Proxy SQL can keep its routing rules in sync without human intervention. This integration helps eliminate single points of failure and ensures the traffic is getting to the healthy database node that it needs to. Proxy SQL is essential for handling database connections in a self-healing setup. Again, provides a lot of advanced traffic management while allowing data updates for zero downtime reconfigurations. Orchestrator, another awesome tool. Orchestrator continuously scans the MySQL topologies. Sorry. Orchestrator continuously scans the MySQL topologies. It gathers replication status, config details, all sorts of data. This enables DBAs to visualize the replication hierarchy in real time. It's got an amazing UI. It's really nice to see. If a failure occurs, Orchestrator highlights issues immediately, which helps us troubleshoot quickly. Orchestrator understands replication dependencies, making it easy to move replicas safely between different primaries. You can drag and drop if you feel the need. This is a particularly useful feature for load balancing, maintenance, or disaster recovery scenarios. Unlike manual topology changes, which can be error-prone, Orchestrator helps prevent unsafe operations and ensure the replication chains remain intact. One of the key advantages of Orchestrator's recovery mechanism is its holistic approach. Instead of just relying on static configurations, it dynamically assesses the current topology state. In case of a primary or source failure, it selects the best failover strategy. It can either automate the recovery process or allow DBAs to manually intervene using all sorts of hooks to execute custom scripts, both before and after the failovers. For monitoring, we use Sensu Go. It provides real-time monitoring of our environment by collecting metrics and logs through lightweight agents. These agents enable dynamic service discovery, automatically registering new databases, and so on. It integrates with other observability tools, Prometheus, ELK, InfluxDB, ensuring seamless data aggregation. Sensu Go operates on a check-based model, continuously evaluating system health. When a failure or degradation is detected, it can trigger alerts and escalate notifications to the DBAs. It's even capable of automated responses, such as executing predefined scripts or triggering external workflows via webhooks. Telegraph. Telegraph is an agent-based monitoring tool designed for minimal resource consumption. It collects system metrics, CPU, memory, network usage, as well as all sorts of MySQL-specific metrics. With over 200 input plugins, it'll easily integrate into your existing observability stacks, such as InfluxDB and Prometheus and so on. Telegraph is continuously streaming data such as MySQL performance metrics, query execution times, replication latency, open connections, you name it. It supports alerting by forwarding data to things like Kafka, messaging queues, custom webhooks, all sorts of data flows there. Combined with visualization tools like Grafana, this helps DBAs detect trends and anomalies before they become critical failures. Beyond monitoring, Telegraph can help enable self-healing automation. You can use it to trigger remediation scripts upon detecting issues, such as high replication latency, unresponsive servers, and so on. If you wanted to do some sort of execution like that where you're kicking something off, it would be the executable output plugin. Telegraph, of course, since Telegraph integrates with Sensu Go, even Capacitor, you name it. Here's our security program we're using, our security suite. This one's one of the few things we're using that's commercial. It really seems to be an amazing product, though. Wiz.io provides full stack security for resources running in the cloud without requiring agents. It continuously scans the cloud environments, detecting misconfigurations, unpatched vulnerabilities, and potential security risks that could expose databases and obviously the rest of your infrastructure. Wiz.io goes beyond basic security scanning by providing contextual threat analysis. For example, it can identify weak authentication settings or excessive privileges that could lead to data breaches. It prioritizes risks based on potential impact and provides actionable remediation steps. For CattleSpa, Wiz.io has Jira automation, which is critical for us to help us keep those CVEs patched. So it's pointing out, for example, there's a CVE on maybe one of our MySQL instances, one of our Apache, whatever. We can even have it create an automated Jira ticket. Again, it'd be part of a pipeline there.
All right, so let's get to the meat of it. This is where the magic's going to happen. If I can click properly. There we go. So what is CattleSpa? For us, it's not a single application. It's a group of tools that Alan's gone over with you. It's a whole system, right? It's self-healing, automated infrastructure. We determine what the desired state's going to be, and it works with our run books to get us back to that desired state anytime we deviate from it. This gives us automated kernel patching, which is extremely important for us, automated service patching. It also helps, like Alan said, protects us against CVEs. and it helps to maintain compliance. We got SOC 2 Type 2 last year. We were very excited about it. The worst one was TextRamp. Oh my God. But we actually successfully got it. That was miserable. But CattleSpa helped us get to where we needed to go for it. It doesn't replace any of our systems engineers, right? But it does empower our systems engineers. The primary drivers behind this, like I had already said, we are a very small but mighty team. CattleSpa helps us do a lot more with a lot less. And we also consider costs and time, right? Like I said, I'm the director of systems engineering, so now I actually have to crunch numbers for a living. CattleSpa helps me to reduce things like unplanned uptime. I don't know about you guys, but sometimes when I'm gone through instances, I will tag an instance and leave myself a reminder that says, hey, let's check this in a week and get rid of it if we don't need it, right? I've forgotten that and have gone back a few months later and somebody's like, what is this? And I'm like, oh my gosh, I forgot to delete that, right? CattleSpa prevents that unplanned uptime from happening. It also helps us to increase our uptime, which is fabulous. It gives our systems engineers more time to focus on helping out our software engineers, which is great. We have a lot of initiatives. We move really fast. And this helps us. We have software engineers that come at us, hey, last year, hey, we want to play with Neo4j. Can you stand it up? I need to get this out by next month. Wait a second. You got to release it next month. You want a POC right now, and I need to stand it up. CattleSpa gives us time. Instead of having to constantly maintain the health of our infrastructure, it gives us that time to focus on it. Even with baseline automation in place, some Puppet, this is a few years ago, it took us 2 to 3 hours to get a new replication cluster stood up, installed, ready to migrate to. If you factor in coordinating with software engineering, change tickets, updating the comms, add another 2 hours of back and forth, a total of 5 hours per replication stack. That's brutal. This, now we're looking at minutes. I say, I need it. It says, okay, here you go. Most of that is Puppet. Unfortunately, I don't want to get into it. We have problems sometimes with Puppet where we have to run it multiple times. That can be kind of painful sometimes. But that's one of the things that we're working through. All right, so with the CVEs that Alan had mentioned earlier, right? Like, things are not getting any better out there. Last year alone, 110 CVEs were released per day, right? And this website that I have linked here, their thing that they're telling you that they need to do, their guidance, is to review these every day. I don't have that kind of time. All right, so one of our patching workflows that we just got done, because we're using Wiz will say, hey, you have a CVE. We'll identify what instances that CVE actually applies to, create a JIRA ticket. That JIRA ticket then kicks off the automation that will patch our instances and put us on new instances. We don't actually patch, we move, right? I can say patch, that's a lie. It stands up a new instance that has the patch applied, and then we're good. But again, that isn't 5 hours of back and forth with a software developer and customer success doing any scheduling. It's just done. And like I said, they tell you to look at this every day, but you can't go on vacation if you do that. You can end up with some pretty nasty CVEs out there. And we have customers that will come at us and be like, what's your response to this? Our response is, we are patched, don't worry about it. All right, so let's talk about a project timeline. In our original state, before we moved to this approach, right, we had monitoring and we alerted anytime our systems deviated from those predefined thresholds, just like everybody else here. We had console running in non-prod because we were playing with it. We heard from somebody that it was a good idea. We used it as a single source of truth, and then we started tinkering around with it. We were like, oh, this would be so cool if we could use console to update our documentation, or move all of our snapshots over to whatever instance we just fell over to. So we played around with it before we actually used it for CattleSpa. We had infrastructure as code with Terraform. That was a nightmare. So if you are not already using Terraform, start. right? Start a lot earlier than you think you need to, because it takes a lot to really organize yourself into Terraform and get it up and running. It changes your perspective on your environment. It really does. It helps you to get organized and start adopting some good systems. All right, so our goal state was to automated patching workflows, right? So here, in our original state, we loved our cows, right? Here, I have no idea what the name of any of these cows are. There's too many of them, all right? So we have a dashboard for reporting. It's not pretty. We are not UI designers. We're not actually at 100% yet, but we're close on our run books, right? Self-healing infrastructure. Something gets broken, something is out of threshold, it gets fixed. If there is an error that is thrown, we send it to what we call the ranch, and a human goes in there and manually addresses whatever the issue might be, right? We're fencing off those troublesome instances. And we have Slack reporting. Communications are really important to this, right? And we also have it set up so that it can page the on-call if we need it to, right? It's very important to remember this is an iterative process. For the past 3 years, we've had 99.997 uptime. Our SLA for our company is 99.9%, but that's not enough for me. I want more, right? Last year, we were down 13 minutes and 42 seconds, and that was planned, all right? It is extremely, I was raised by a single mom. That is my person. And if my mom did not have access to her materials, she would have had a bad day. And she would have brought that bad day home, right? This way, I feel like I'm taking care of those people, all right? 99.97. Infrastructure is code to all the things. If you do not have Terraform, OpenTofu, whatever your poison is, really get started on that, okay? This is an iterative process. Don't feel overwhelmed by it. In order for us to meet any of these goals, we had to allow those iterations. One thing that was really cool and really important to remember, I just put the word modular down here. It's not enough of a word to describe it. Every single thing that we did towards this system put us in a better place than we were before we released that part. Every tiny part of this matters towards you having a better infrastructure than you did before you started. All right, so I said we're not UI engineers, but there are a few things that you need to remember when you're doing this, okay? You need to be able to look at this and very quickly say, oh, this one's fenced off. That's the red name there, right? You need to be able to look at it and see where are my errors. My CPU is running hot. We don't exactly do percentage use CPU because that's like I'm waiting in line at a DMV. We use load instead. It means more for us. RAM, disk, things that are really, I'm going to go in there, I'm going to spot check it, and I'm going to move on. And then I include links to my logs, any pertinent logs, and then links to the Wiz or whatever your security suite is. It's a lot better to look at a UI than it is to wade through logs. All right, so I said don't get overwhelmed, okay? So let's walk through a 5-year process of what something like this could look like, all right? So breaking it down, in year 1, you're going to get your infrastructure as code. This is going to take you longer than you think it is going to, all right? You're going to have a lot of arguments, you're going to have a lot of blood, sweat, and tears, and then you're going to get it done. Configuration management is extremely critical. Good configuration management gives you documentation of your system, gives you a backup of your system. That's fabulous. All right, if something really goes wrong for us, we have that backup that we can lean into. Like I said, if you don't like Terraform because of the license change, I feel you. Look at OpenTofu. It's nice. Get console up and play with it. Console's really powerful. It's just a KV store. But having that single source of truth, it gives us so much that we can play with, from Slack Ops to, integrating with our wiki, things like that. Get your security suite. up and running, get Jira integrated with it. If you don't control that part of your stack, I get that. Talk to the people who do control it and let them know that CattleSpa is going to make them look good because you're going to reduce their critical tickets, okay? And like Alan said, write any of your run books for automation. Your engineers will love you at 3 a.m. when they just don't have a bunch of text to run through. They can just do what they need to do. And spend this year getting excited. All right, year 2, you're looking at getting Orchestrator, Proxy SQL, things that really are going to control your database topology and help inform your applications who they need to talk to. You don't want them stranded. You establish the baseline, rules to follow. I don't like following rules, so I call them guidelines. It's just a personal preference. But get them in place. What matters the most to you? All right? That uptime mattered the most to me. For some people, their data matters the most to them. So make those decisions. Sometimes you have to pay prices on a different end than you might expect. So figure out what your guidelines are. Write your run books. Set up a quarterly review. Really review your run books. Don't just put them up there and then move on. Just because something's not complaining doesn't mean it's doing a good job. We in year 2, we have our logging cluster fully in CattleSpa. We have non-prod databases fully on CattleSpa. So we get a great idea of how it's working. And what we're also getting in year 2 by having non-prod databases in CattleSpa is trust, okay? When you have a fully automated system, trust is very important. Your pointy-haired people that are running your company, they need to not put a stop to the system that you have because they have lost trust in it. Communication is a huge part of this. And by comms, I'm not talking about you sitting down talking about your feelings. I'm talking about in Slack, it says everything, major decisions that's being made, so that they can come in and they can look. Your directors are starting to feel a lot more comfortable about this. They see what it's doing for you in non-prod. You have a good dashboard at the end of year 2. Year 3, review your tooling and upgrade or replace it, okay? Don't be using something you used 5 or 6 years ago. Please review your tooling every couple of years. This is a very important part of CattleSpa. It's a mentality, right? It's a mentality and it's a system. Adopt it. Your production databases start rolling out onto CattleSpa. This is super exciting. Review and update your config management. And then your operating system and your kernel patches are going out. Your database patches are going out. 50% of your stack should be on CattleSpa by the end of year 3. So this is the magic year. This, you know exactly what your dashboard should look like, so you're going to put out a 2.0. If you need to do anything once, you have written a run book for it, and you have it in the system where it's appropriate. Very few things are requiring your hands-on right now. You're focusing on keeping up with the ever-changing cloud and AI tools that are out there. Feels like it's every single day there's something new that I need to be an expert on. You're focusing on increasing your software engineers' understanding of your stack, right? We do a lot of office hours and a lot of training for our software engineers so that they know how to use Google Cloud. There's a lot out there. We are primarily, I'm not sure if I said that in the beginning, we are maybe 70% Google Cloud, a little bit AWS, very tiny amount of Azure. It's our IT, if I'm being honest. And then OCI. We use Oracle Cloud also for our financials. So we have a lot of different types of software engineers that we're having to teach. In this, you're also driving innovation during your free time. And maybe you're playing solitary all day. I have no judgment. So 5 years. By the end of 5 years, you should be fully operational and things should be comfortable. Like I said, every tiny thing you do towards CattleSpa puts you in a better place than you were. All right? Don't get overwhelmed by how large the system seems. With license changes and new tools coming out all of the time, it's important to keep up with it. You're going to spend year 5 doing the same thing that you were doing in year 3 and reviewing your tooling. All right, so let's go through a sample workflow. All right, so let's say that I have a common vulnerabilities and exposure is released. It's released against Ubuntu. A patch is released to address it. A few days later, it's never immediate. And I say a few days, but let's be frank, it's usually a couple weeks. Let's say that 8 of our database instances have been tagged as being vulnerable. We need to address it now. 8 instances get flagged for upgrade. New instances are stood up alongside of those original 8. The new instances have the updated kernel patch. Puppet successfully runs. Console templates update proxy SQL to add the new instances to the appropriate secrets based on the instance name that we talked about earlier. After this, the new VM gets deployed. It runs in parallel to the old one. Puppet reports it's successful. Yay, everything looks good. The dashboard is green right, well, the dashboard's actually yellow right now because it's in progress. These 8 VMs are now replicating with our desired topology. Performance and resource usage looks good. Then we have a problem. Console health checks run, and it initially says things are great. It's handling traffic properly, but one of them throws an error just at that 11th hour. Let's say that there's a network partition hiccup that causes a problem mid-process. It gets recycled, and the original VM gets flagged to restart the process. This takes a lot longer to say than it does to happen. On those original 7, new VMs are created. The original 7 new VMs that are created. The read-only flag is set to on. The new 7 get it set to off. Proxy SQL routes traffic to the new VMs. Any issues during the transition will flag the old VMs to go to the ranch, like I said, so that a human can come in and take a look. This is a pair process. We don't let our automation just go have fun yet. We still, whenever it throws errors, we will step in and take a look and see what the problem is. The old VMs are removed from proxy SQL via console templates, like Alan had mentioned earlier. And if there's no issues, those original 7s get flagged to be deleted in a predetermined number of days by CattleSpa, not by me. So again, unplanned uptime. My goal at the end of this was to reduce our unplanned uptime by down to no more than 5% of our cloud spend. Our unplanned uptime is way less than 5% of our cloud spend right now. It used to be, when we started this, over 15% of our cloud spend was unplanned uptime. All right, so final thoughts. We're going to use Puppet manifests to automate the entire process. Now, this requires a little bit of a mental shift to the future. Let's take both feet out of the data center, please. Patching is not going to be during off-peak hours. There are no off-peak hours for us. We just hired a new engineer that is in Serbia. We have clients that are all over the world. We don't have off-peak hours. That's not a thing. That's back when we were in the data center. It's not now. And this is a continuous process. And that continuous process allows us to, like I said, increase the trust that the people who lead our company have in our automated system. A human at any time can implement a rollback. A human at any time can step in and say, no, this does not work. We always fail forward or fall forward. I forget how you put that. But we always fall forward, right? We try our best not to ever roll back if we don't have to. Sometimes we have to. We are working on allowing the CattleSpa system to make that decision and do the fail forward, but right now we just throw everything in the ranch and we go take a look at it. Doesn't happen that often. Our databases, after receiving writes, we never go back, period. We always move forward. And as I said already, our troublesome instances get ranched. So, extensive monitoring and alerting through the entire thing. We configure our alerts so that any anomalies, anything that happens in this process gets raised, the awareness. And then we use console health checks and proxy SQL logs all the way through the process. Thank you. Thank you. So document the patching process, including the steps and the scripts. Document everything. CattleSpa communications, we have straight into Slack. We keep our stakeholders informed. Hey, your database was rolled over to a new set. It was patched against this CVE yesterday. You're good to go. So we keep our stakeholders informed the entire time of anything. And any major version upgrades right now, we have, because it does require software engineers to make sure their applications are going to be working on MySQL 9, for example. That's something that we have to go in and manually tag for an upgrade. So we know that our software is ready for that version upgrade, especially with the databases. And then CattleSpa takes it from there during its next run. So to wrap it up, to put a bow on it, get CattleSpa in your own environment. You start with your expectations. I really don't like the word rules. So for us, stability, cost, security, specifically, maintain our 99.97% uptime, reduce unplanned uptime to below 5% of our cloud spend, decrease resource turnaround time, that's huge for us, and keep our systems patched. To do this, we adopt an infrastructure as code. If you're not doing this, get busy. The process of adoption takes a lot longer to actually do than it takes to consider it, so get busy on that. When you're evaluating tools, take a look at our list, change them. All of these tools that we have are interchangeable with other tools that are out there that might suit your needs a little bit more. And remember, most important thing here, review, iterate, review, iterate. Okay, don't be afraid of that. Any questions? Yes. Yes, ma'am. No, we do not run MySQL cluster. We use replicas, yeah. So the question is, do we use MySQL cluster? We do not. We use replicas, traditional replication. So we actually support over 30 applications and even more microservices. So we have anything from one database that we are running about, I'm trying to think, it's like 800. Our largest database is around a little under 100 terabytes. And our smallest database is under. It can. So we actually use snapshots, database snapshots in cloud, right? And it takes, for our absolute largest databases, it takes us under 7 minutes to bring up a new disk from snapshot. So that's still programmatically really fast in comparison to a human going through and doing it. Yeah. Do I have issues with warming up the snapshots? No. We have never had any, not in GCP, we've never had any issues with warming up the snapshots. Yeah. Yes, sir. Yeah, so we have, what's our team size that we have in comparison to what we're managing? So we have 7 people on our team. Some, including 2 lead engineers. The actual hands-on that this is not replacing, but helping out, is 4 people, right? It's 4 people with an engineering team of 500, and all of the databases and applications and microservices that we're managing. We continue to grow every year. Like just since last year, we've doubled our software engineering team. We have not doubled our team. Any other questions? All right, fabulous. Thank you so much.
Thank you, everybody. works.
Okay, it's 12:30. I'm going to get started. Can you hear me okay in the back? Awesome. So welcome to the session, Hidden Gems in MySQL Shell. I will fully admit that all of these might not be hidden, but I can guarantee you that they are all gems. My name is Scott Strohs. I am a MySQL developer advocate, MySQL developer advocate for Oracle. Before we get started, the obligatory I love me slide. I am a full stack developer, and I have been a full stack developer for longer than the term full stack developer has been in existence. Back then, we just used to call ourselves developers. In the entire time I've worked as a developer, MySQL has been the only constant in my development stack. I used MySQL in my first job as a web developer. I still use it now, and I've used it on a variety of projects since, some large, some small, some private, some for the US government. Well, interesting fact about myself is I used to be a paramedic. I was a paramedic for 14 years before I became a developer, and in that time, I actually delivered 3 babies. One of them, their middle name is Scott because I delivered him in the back of a moving ambulance. I suggest not doing that because it's not fun even when you're trained. I like giving things away at my talks. Yes, it's a little bit of bribery. I'm not above bribery. I want people in the seats to hear me talk. And I want you guys to pay attention to everything I say and everything you see on the screen, because at the end of the talk, I'm going to ask you a question about something I said or something you saw, and whoever is the first person to get the question right is going to win a dolphin. This one. Okay? Now, I know right now people are like, oh, but here's the thing. This is a special limited edition 30th anniversary dolphin. We do give these away at the conferences. I can tell you that whoever gets this will be one of the first people in the United States to have a 30th anniversary limited edition SCaLE plushie. So pay attention. And then lastly, this is my dog Murphy. He is my best friend in the entire world. He spends all day, every day in the office with me, which is awesome because when I want to talk through a problem, looking into those eyes while I'm talking to him somehow magically allows me to solve the problem all the time. But this is Murphy when he was a puppy. This is Murphy as the 112-pound beast that he is today. He's an awesome, awesome dog. So, how many people here use MySQL Shell? Oh, not as many as I hoped, but that's actually pretty cool. So, what is MySQL Shell? Put simply, it is a modern CLI that can be used to connect and manage MySQL instances. There are multiple different modes you can use. JavaScript mode means that the commands you're going to execute are JavaScript syntax. Python mode is the commands are going to be in Python syntax. SQL mode is the equivalent to what we used to do when you did the MySQL executable and logged in. So you have a SQL mode where you can run commands, or you can run queries, you can run insert, update, delete, you can set variables however you want. Any command you could run through the MySQL executable, you can run through MySQL Shell. And it has many, 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 many useful features beyond what I just mentioned. And that's what this talk is about. But unfortunately, I couldn't talk about all of them because that would be like a 2-day workshop to talk about everything that MySQL Shell can do. So I just tried to pick the things that I find to be the most useful. The first one is sandboxes. Now, when I want to play around, when I want to try to test some stuff, and I don't want to clutter up my main repo on my desktop, I use sandboxes all the time. And what a sandbox is, it's a self-contained MySQL instance that runs on your local machine. It runs on a different port number than the default that you have, or than what you have running normally. By default, that's 3306. These instances are only available on local hosts, so if I had a sandbox instance set up on my machine and you were connected to the same network, you could not access that instance. And you must have MySQL installed on the machine that you're trying to create the sandbox on. So if I tried to create a sandbox on my laptop, so I have Shell installed on my laptop, but I don't have MySQL installed, it's not going to work. It's going to throw an error. And the command to deploy an instance, or sandbox instance, is dba.deploy sandbox instance. And then the argument we're passing here is the port number that we want to use for this instance. So when this is done being deployed, I will have an instance of MySQL running on my local machine. with the port number of 3336. Now you can pass in options, so there's an options block that you could pass into the deploy sandbox instance where you can provide the password, but to me that's more typing because I have to put brackets and then password and then comma and then the password, or colon and then the password. If you just let it go through, it'll tell you it's building it up, and then enter the root password, you enter in the password. It'll tell you it's deploying a new instance, and then bam, the new instance is deployed. So after running this one command, I now have two instances, at least two instances of MySQL running on my machine, the main one and the one that we just created. Now here, you'll see in the instructions say you can use shell.connect root at localhost 3336 to connect to the instance. But I'm lazy, I don't like typing, so I just use the \C shortcut to connect and do root at localhost 3336. And then I'll say it's connecting to a session, provide the password that you just created, and it will actually give you the same message as if you were connecting to any other SQL instance, MySQL instance. Managing sandboxes beyond deploy, there is stop sandbox instance. What stop sandbox instance does is that is actually a nice gradual shutdown. So this was as if you went into MySQL and you shut it down manually to reboot the server. Start sandbox instance, if you have an instance that's stopped, so you already created it, you were playing with it, you shut it down, you stopped it rather, you can use start sandbox instance in the same port and it will spin it up again. Kill sandbox instance is an interesting one because that is actually what you can use to simulate a hard failure. So this would be like your server crashed. It wasn't a graceful shutdown. It was, bam, you're done. And the reason why you can use sandboxes, or one thing you can use sandboxes for, is creating clusters and creating read replicas. And by using kill sandbox, you can make sure that your configuration is set up. So for instance, if you have a primary node for a read replica or a cluster, and then you have secondary nodes, and you do kill sandbox instance on the primary node, you can actually then test to make sure that one of the secondary nodes is going to become the primary. And then once you're done, because it does take up some hardware, some hard drive space, is you can do delete sandbox instance, or you can simply go in and delete the folder in the path where it is. It varies depending on the operating system. Server upgrade check. This I actually find very useful, especially if you're dealing with databases that have been not upgraded in a while. So maybe not necessarily from 5.7 to 9.2, but if you have something in the 8.0 range and you want to go on to the new innovation or the LTS releases, this comes in really, really handy. So you can actually use MySQL shell to check to see if a particular database or database instance is compatible with a version that you want to upgrade to. Now, by default, MySQL shell will use the version of MySQL shell as the version we're checking for. So if I'm running MySQL 9.1 on my laptop and I'm running MySQL shell 9.2, it will check to make sure that the version that 9.1 is going to be compatible with 9.2, but you can configure that. That's actually an option you can pass in to say, use this, basically it says use this version, and you can check other versions. And that particular command is util check for server upgrade. Now, I love MySQL. I've been using MySQL for a long time. The one thing the MySQL team is not very good at is naming things. So a lot of these methods are really long, and unfortunately in MySQL shell there's not like code completion. So sometimes if you're like me, I'm a poor typist, it'll take me 5 or 6 times before I get the spelling right to get the command to run. But once we run this command, so the examples I'm going to show, I ran this command against some old data that I had on my local machine. And it tells you that the local server running at host 33060, version 9.01, community server will now be checked to make sure that it's compatible with MySQL 9.2. Now keep in mind, when you do the server upgrade check, you have to be logged into that instance on shell. That doesn't mean you have to be physically at that machine. So if I logged into shell on my production server, and ran this command, it would check the production server over what's on my local machine. So it's whatever instance you're connected to, not necessarily the machine you're actually sitting at. In this particular case, it was the machine I'm sitting at, but that's not always going to be the case. So the first thing the upgrade check does is it checks to make sure that if there's any problems with system variables. Sometimes system variables get deprecated, sometimes there's new ones, sometimes the names change. And this is just making sure that there's nothing in your database schema that is going to cause problems with any changes that may have happened. The next check is it checks the different tables to make sure they're upgraded. In this particular case, the MySQL REST service metadata object fields with references, see I told you they're not very good at naming things, is using UTF-8 MB3, which is deprecated. It should be upgraded to UTF-8 MB4. And then it checks for syntax issues with any type of database object. So that could be tables, it could be stored procedures, stored functions, views. And here you'll see that the MySQL InnoDB cluster metadata .v2 set routing option, there's a couple of problems with those columns in the MySQL InnoDB cluster metadata database. And this is basically just saying, hey, there's a syntax error here. And what's cool is the fact that it gives you a link to whatever the problem might be. The next check is to make sure if foreign keys are referencing full unique indexes. In this particular case, I have 3 columns that are not using or not referencing full unique indexes. So it breaks down what the table and the column are. And then the really cool thing is it gives you solutions on how to fix those particular issues. So it tells you, hey, this is a problem we have with this column not using a full unique index. Here's how you can fix it. And then it checks for any deprecated or invalid user authentication messages. Of course, here there was none found. Then it gives you a summary of how many errors, warnings, and notices that you have. Again, it says here that I had 4 errors. What that means is before I can do the upgrade, I have to fix them. You have to fix the errors. You don't have to fix the warnings or the notices. Advanced data dump. How many people here use MySQL dump? I'm putting my hand up because I used to. I stopped because of this. In MySQL Shell, we can actually do dumps that I think are better than MySQL dump. And the reason why is it's very easy to specify specific tables, specific schemas, or we can actually just dump an entire instance at one time with one command. The dumps are multi-threaded, which is where you're going to get performance increases over MySQL dump. By default, it's 4 threads. Now, don't think, oh, I'll just keep adding more threads, because eventually, if you take up more threads, the performance is going to take a hit. On my laptop, anything beyond 12 threads didn't perform as well as 12 threads. As a matter of fact, sometimes going above 12 threads performed worse than 4 threads. So if you have a huge data set, you might need to tweak that a little bit to make sure you're getting the best throughput. When you dump the data, you can actually provide a where clause that says, when I'm dumping the data from this particular table, I only want it when this particular column equals this particular value. So if you only need a subset of your data to be moved somewhere else, this is one way you can handle it. You can also dump your data, or you can do your dump directly to a cloud provider. So you could do this directly to a storage bucket in OCI, AWS, Azure, or any cloud provider that has S3 compatible functionality. So you can take your data from wherever it is, and as long as the computer you're running the command on has access to both environments, you'll be able to dump that data from wherever the database is into a storage bucket in the cloud. And also, if you're contemplating moving your on-prem databases to into HeatWave MySQL, then there's actually a way that you can specify that when you do the dump to do a check to make sure that the database is actually compatible with HeatWave MySQL. So to dump the entire instance. Now, when you do a dump instance, it will dump every database object in your instance except for the system tables. So it won't dump the MySQL table, the MySQL performance table, and even some of the ones you saw there where it was like the MySQL REST services and clustering stuff. It won't dump those. It only dumps the database objects that we created. Again, tables, stored procedures, functions, views, events, those are all done through, you can all get those with dump instance. Dump schemas, when you do dump schemas, the first argument, let me back up here. So you'll see here that the first argument here is basically the location on the machine where you're running shell that you want the dump to be stored. Obviously, it's going to be different. It's going to be slightly different if you're dumping to the cloud, but I have an example of that in a second. And then you specify there's an option object. So the dump instance, dump schemas, dump tables, they all have the last optional object of being, or last optional argument of being an options block in JSON. So here we're saying we want to dump this using 8 threads. So when I do dump instance running this command, it'll actually use 8 threads to dump all the data. In this particular example, we're saying, hey, we just want to dump the MySQL shorts schema that exists on this instance, and we're going to dump it to the dumps folder, or I'm sorry, the example2 folder, which is in the dumps folder, which is in the root for my user in this particular thing. Again, we're saying threads equals 8. If you notice, there's actually is a typo here, I apologize. There should be another bracket after the single tick after MySQL shorts. That's an array, so you can actually specify more than one schema that you want to dump when you run this command. It doesn't have to be just one, it doesn't have to be all. And then we have util.dump tables. I don't know who came up with the idea to use dump for all of these, but whenever I give this talk, about this time I start losing it because I've said dump so many times. But for dump tables, the first argument is the schema that you want to use. The second argument is an array of table names that you want to use, and then the third argument is the path that you want the dump to be stored. And again, I could have used a fourth argument, which would have been the options that I wanted to use. Now, quick question: whoever gets this question right is going to get a lollipop. This is not the question for the dolphin. When I run this command, how many threads are going to be used? You want to catch it? Oh, I almost made it. Sorry. That's right. By default, it uses 4 threads. So here's an example where we're using dump tables where we're specifying a where clause. So in this particular case, we want to dump the table named games that exists in the MySQL short schema, but we only want to dump rows where the score column has a value equal to or greater than 90. So when we run this command, we're going to have a lot less data in the games table, in the dump, than we would in the previous command because we're filtering the data as we're doing the dump. And to do dump instance, this is how you dump it to the cloud. So in this particular case, this would actually dump this to a folder named example5 in my instance of OCI in a storage bucket named database_dumps. Now, I will tell you that if you're going to try this and you're using OCI, you will probably need to include more information in the option. Particularly, you're probably going to need to include the compartment ID. But I have my setup I have my OCI configured on my local machine so that the compartment ID is included whenever I connect, because I don't want to have to include that all the time, again, because I'm bad typing. So it does it for me automatically. And then if you want to check to make sure that what you're dumping is compatible with HeatWave MySQL, the option you use is OCI MDS, and you set it to true. Now, the reason why it's OCI MDS, OCI obviously is Oracle Cloud Infrastructure. The MDS, you're probably confused because MDS is actually an acronym for the former name of HeatWave MySQL, which used to be MySQL Database Service. So that's why it's OCI MDS for that particular option. And then when you output the data, there's actually a combination of, you can see there's SQL files there. There's also JSON files, and then there's the ZST and IDX files. The ZST files are binary files, and the SQL files, if I remember correctly, those are actually like what's going to actually create the tables. So it runs a SQL script to create the tables, and then the binary file so it actually contains the data. So it reads that almost like the bin log to populate the tables. And the JSON files will include information about the dump, but also include information about any loads that you may have done. So if you try to do a load of this data on the same system twice, it's going to go, oh, we did this already. And you can actually, you can override that. But what's cool is the fact that, and also if there's an error when you're doing the load, and then you fix the error, you could try the load again and it'll pick up where it left off. So advanced data loading. This is so if you're going to dump data, obviously you're going to need to load data. And again, if you're using MySQL dump, a lot of times you just kind of run the script that's generated because it just generates a crap ton of SQL files. Anytime you dump data using dump tables, dump schemas, or dump instance can be loaded using, there's only one method this time called load dump. And again, this process can be multi-threaded. Again, the default is 4 threads. You can actually improve performance on loading the data by using an option in the options block that you pass into load dump that turns off writing to the bin log while you're loading the data. So if you're loading a lot of data and you don't turn off the bin log, it's going to take longer to do that because it has to write everything to the bin log. But if you're spinning up a new instance and you're moving this data over, do you really need the bin log? No, because you have the backup that you just took. You have the dump that you just took. So if something went wrong, you just run the dump again. And you can actually load data from cloud providers. Again, OCI, AWS, Azure, anything that supports S3, or anything that's S3 compatible. If you have your data stored in that particular cloud provider, you can use the path to that cloud provider using load dump, and it'll read the stuff from the cloud provider and put it into your database. I've actually done examples for people before where I have a MySQL database running in Azure, and I want to move that data to a particular server in OCI, but I want to store it in AWS first. So I run dump instance on the Azure instance, and I store that information in AWS, and then I run load dump against the OCI instance and pull the data from AWS. So in 2 commands, I move the database from one cloud provider to another, but through a third. You don't need to do it that way. I just thought it would be a fun example to show that it could be done. And another cool thing is the fact that if the data you're dumping does not support or does not have invisible primary key, so if you have a table somewhere or that does not have a primary key, you can specify that when you load the data to create an invisible primary key, which is something that the MySQL will use it as a primary key, but you'll never see it in your queries because it's invisible. So before you can actually load any of the data, you need to make sure that the local in-file global variable is set to on. If you don't, it's going to tell you, hey, you need to set the global variable local in-file to on. It's probably not a good idea to keep this on all the time, so as soon as you're done, you should probably run the command. So this command is to turn it on. You run a similar command, you specify it to off. Also, if you want, you can use 1 and 0 for on and off rather than the actual text on and off. Either one of them work. So here, we're specifying that we want to load the dump that was in the example2 file, and we're going to load it using 8 threads. Again, you might need to play with that. If you do 24 threads, you might not get as good a performance as you would from using a lower number. So if you want to skip the bin log, the option you want to use is skip bin log true. And what will happen is when this starts the load process, it will turn off writing to the bin log. Once the load process is done, it will turn on writing to the bin log again. So everything you load will not be part of the bin log, and that's actually going to make the performance of loading the data much, much faster. Here's an example. Again, this is an example I used for my my account in OCI, my corporate account in OCI, where I can pass an OS bucket name, and it will look in the database dumps bucket for a folder named example2, and then it will actually pull the data from there rather than anywhere on my local system. And the option for creating invisible primary keys is create invisible PKs. You can set that to true. Again, that is, you can use that if you're going from one instance or one version to another, or if you're going to the cloud. On HeatWave MySQL, every table has to have a primary key, or it has to have an invisible primary key defined. So those two pieces of functionality are very helpful. I use dump, I probably use dump schemas more than anything else. I use dump schemas and load dump all the time, multiple times during the week when I'm playing around with stuff at work and I want to test stuff and see how things are working and pull data from one place and use it locally. But sometimes you don't want to do two different commands. Sometimes you're just like, you know what, I don't need the data locally. I just want the data to go from server A to server B. So here, we can actually copy data directly between two instances with a single command. So again, you can copy specific tables, specific schemas, or an entire instance. Again, remember when you do the instance, it doesn't copy the system tables. And what's cool here is the data, we can also filter the data here as well. Now, just so we're clear, this does actually take a dump and put it onto whatever machine you're running shell on and then do a load from that, and then it removes the dump. So it's going through the same process. You just only have to run one command, and then you don't have to worry about clearing out the folders or files when you're done. On the source system, so wherever you're moving the data to, you need to make sure you have local in-file set to on. If it's not, you're going to get an error telling you to turn it on. On the target system, this is where you're moving the data to. This has to be set. So then if we do copy tables, and we say we want to use the MySQL shorts schema and the games table, and then the third argument here is the instance we're actually going to be pushing the data to, which here you'll see it's root at local host 3336, which, if you guys are paying attention, was one of the sandboxes that I created earlier in the talk. I like reusing the stuff like that. The copy schemas, here it just copies the entire MySQL short schema to the same instance. Copy instance, and and then remember when you run these on the source system. So you need to be connected to the instance that is the source of the data, and then the connection is going to be the target. So I'm reading this. I was logged into my normal instance, so on 3306, and I want to push it to 3336, and that's what this is going to do. Again, something important to remember, it will not copy the system tables. And here again, if you want to have a where clause, so we only want to move instance from server A to server B, where the games column in the MySQL shorts schema is greater than 90. Now you can actually include multiple where clauses, and you can include multiple where clauses for different columns in different tables, even in different schemas, if you're doing the dump instance. Okay, so you can get pretty complex with what you need. You just need to make sure that you do the full path. So you have schema dot table name in the where clause, and then I said if I had another if I was doing copy instance, I could put where demo5 dot name greater than or equals Scott, something along those lines, which would probably be a good example to put in this talk. Mental note. So what we've talked about so far, if taking the where clause out of the equation, it's kind of like doing a full backup and then a full restore in a way, because we're saying, again, take the where clause out of the equation there. We're saying, give me all the data for these particular pieces, and we take that and then we push all that data. And that can come in handy for stuff that you do. I actually have a personal project where I frequently need to pull data down from the production database. and put it on my local machine. Like if something happens where somebody has an issue that they're running into and I can't reproduce it, so I need the data, I actually have it set up so I have one command that I run on my machine, and it runs a dump and then a load into the database, and literally within like 10 seconds I have the production database running on my local machine. But if you had a really big data set, that could be cumbersome. And by dumping bin logs, we can actually kind of do, in a way, an incremental backup and restore. I'm going to explain how it works in a second. So first of all, dumping the bin logs is new in 9.2 of MySQL Shell, which came out very recently. Funny thing is, the last time I gave this talk, somebody had a question, and I wasn't too sure of what the answer was. So when my talk was over, I looked it up, and that's when I found this feature. I was like, oh wait, I need to add this to the next time I give the talk. Some of the requirements: the source you must have binary logging enabled, because if you don't have binary logging enabled, there is no bin log, so therefore you have nothing to copy. The GTID mode global variable needs to either be on or on permissive. If it's off or off permissive, it's not going to work, and you'll get an error. Like everything else we've talked about, when you do the dump, you can actually dump it to storage buckets in OCI, AWS, Azure, or anything that is S3 compatible. And it must be used with data that was dumped using dump instance or a previous dump bin logs. And the reason why that is because when you do bin logs, when you do copy bin logs, or sorry, dump bin logs, you actually need to specify a starting point. And what you do with the starting point is you actually point it to the folder that contains the dump from the dump instance or from the last dump bin logs. And that's how it knows, okay, when you did dump instance, you went up to this particular point in the bin log. I know I need to copy everything from that point on, or dump from that point on. So that's how it does the kind of incremental backup. So I'm going to assume, or we're all going to assume, that I did a dump instance on my local machine, and then I restored that instance using load dump into one of my sandbox instances. So now I have two identical systems in terms of MySQL. And then on the primary, so on server A, I run a query that says insert into mysql.pets, name, type, values, Molly dog. Actually, that should say MySQL shorts. There's a typo there. I apologize for that. So now we have a change in the source. And that change has happened since we did the dump instance. So now what we do is we call util.dumpBinLogs. And then we pass in the arguments block, we do since. So basically we're saying, I want to get all the bin logs since this happened, and the since we point to, in this particular case, is the folder where the instance dump happened. If I did another dump bin logs after this, I could specify that the since was where this one gets created. So I can do the since dump / bin log. And then you'll see it'll give you some information saying that it's starting from the previous dump, and it tells you, what binary log, what log file it starts from, what log file it finishes on, how many bin logs were dumped, how long it took, what the compression ratio is, blah, 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 blah. So now I have the dump of the bin logs, which is nice. But now we need to know how to load them. So now on my sandbox instance, I'd have to connect to my sandbox instance. I could run dump bin logs. I'm sorry, this should say loading bin logs. Again, new in 9.2. The requirements for this is the directory you use to load must contain a dump from dump bin logs. If you try to do a load bin logs on a folder that wasn't done using dump bin logs, it's going to throw an error, because if you didn't dump the bin logs, you can't load the bin logs. The dump must be compatible with the version of the target. So if you're dealing with different versions, you need to make sure that when you dump it, the version is going to be compatible. And this is the important one, and I didn't understand this, and I had to ask somebody, I'm like, why is this important? And they said, because sometimes when you dump bin logs, if there's been a lot of data, there's been a lot of changes, the bin logs take a while to be dumped. If you try to load it before they're done, you're going to get an error. And I'm like, okay, but did we really need to put that in there? And apparently we did. So here, again, now I'm on my source. I'm on one of my sandbox instances that I created. And I do load bin logs, and I point to the bin log dump that I just created. And here I'm using the option ignore GTID gap. And the reason why I did this is because when I tried to load this without that option, I got an error, and I don't know why it was saying there was a gap in the GTID when it shouldn't have been, because they should have been identical, but they weren't. But here, by saying ignore any gaps in the GTID, it'll skip over that gap, and it'll continue with loading the binary data. And then you'll see here, it says there's a warning, there is some missing transaction, which I discovered, and I got around it by using the ignore GTID gap. And then it goes through and it gives you information that's loading information, and it processes the bin logs. And then once it's done, if we do select star from MySQL shorts.pets on the target database, we'll actually see that Molly is included in that particular case now. So it's kind of handy if you need to move data across systems and you have a lot of data and you don't necessarily want to bring all of the data every time. It actually uses a very similar process to replication, because replication in MySQL uses the bin logs to move the data back and forth and to know what data has been replicated and what data has not. Creating a replica set in MySQL shell is ridiculously easy. For a lollipop, how many commands do you think I need to run in MySQL shell to create a replica set? 2! You know, I'm sorry. I used to use like the old style. My wife found like the original Tootsie Pops that are like the size they were when we were all kids. They're huge, and they go farther when you throw them. And I had to go with the regular cheap ones from today. So yes, you can actually create a replica set in MySQL shell that has one primary node, one secondary node with 2 commands. And the cool thing is, you can test this using sandboxes. So if you needed to create some type of high availability, or you wanted to do some type of replica set, but you didn't want to screw things up in production, or you didn't want to spin up instances and have it cost money while you troubleshoot stuff, you can use sandbox instances on your local machine to set this up. So the command to actually create the replica set, this needs to be executed on the primary. So it needs to be executed when you're connected to the primary. So whatever instance you want to be your primary MySQL server in the replica set, you connect to that using MySQL shell, and then you run the command dba.createReplicaSet, and then you pass the name. Now what I've done here in the beginning, you see it says var rs equals, and then the command. That means that whatever is returned from the dba.createReplicaSet command will then be available in the rs variable for the rest of the session, or until I overwrite it. So now, I'm going to go back here. So this will say the new replica set instance with port number 5555 is going to be created. It checks to make sure the instance, and it goes through some data checks, and it says, hey, you're good. The replica set's created. But right now, it's not really a replica set because it just has the primary. You really can't have a replica set if you don't have something you're replicating to. Here you see, instead of having to do anything else, I can just do rs. So this is why I set that variable, because it makes it easier to get to run other commands. I could get that by doing some other long command process, but this is a lot easier. Again, I don't like to type. So now we do rs.addInstance, and we specify the connection string for what is going to be the secondary node in our replica set, which is root at localhost 5556. And when you do that, it says it's adding the instance to the replica set, performs validation checks, it does a bunch of checking on stuff. And then you're going to get a message like this. And basically what this is saying is, if things ever get out of whack, and the GTID on the primary, or the most recent GTID run on the primary doesn't match the most recent GTID on the secondary, how do you want to fix that? And I've only ever done clone, which means when there's a problem, the GTIDs don't match, it simply clones the data over to the replica. Now, once they're replicated, you shouldn't have that problem again because the data should automatically be moved. But if it does, it's going to use clone rather than anything else. And it does, you also have an option of using incremental, so it'll do changes incrementally rather than just cloning the whole thing. And then you get messages about upgrading the topology of the cluster set, and it's talking about the file copy, the page copy, the redo copy. And it goes through a bunch of stuff. And again, if you have a lot of data, if there's a big instance that you're dealing with here, this is going to take a while. This actually takes a little while, even just with like an empty data set. And then once that's all done, if you do rs.status, again, because as long as we're still connected, rs points to the replica set that we created, you'll see a JSON blob shows up on the screen, and the 2 points that I wanted to highlight here is the fact that the primary is localhost 5555, and the secondary is localhost 5556. Now, I could add more instances to this replica set by using that same command if I wanted, which is going to be useful if you're in the cloud. You can actually put replica sets in different areas or different recovery regions. So it's actually really helpful. If anybody has ever tried setting up a replica set before, it's not difficult, but it's not that easy either. I mean, just being able to use that 2 commands, we created a replica set. And how many people here don't know what I mean when I say replica set? Yes. This is something I find extremely helpful because I hate toggling back and forth between MySQL shell, where, believe it or not, I tend to spend a lot of my time during the day, and going into a regular terminal to run commands. We can actually run system commands from inside of MySQL shell. The results that you get, so if you run a command that would output data, it actually shows up inside of shell. And you can even run commands as sudo if you need to, which again, that could come in helpful if you are connected to a remote instance that maybe isn't cloud-based, but you have some type of remote instance where MySQL is installed on that instance. You can then run system commands against that system. And basically it's \system, and here I'm doing \system ls-la, and it's telling me to show the contents of the project/cell scripts. And you'll see it actually shows the output in MySQL shell just as if you ran this in a regular terminal window. Now again, because I'm lazy and I don't like typing, the shortcut for system is exclamation point. So I can do \exclamation point, and here you see I'm doing sudo ls, and then I want to list what's in the root. It'll prompt you for your password, your sudo password, and then once you get that, it'll display the information. Again, this is all inside of MySQL shell. You won't need to do anything else. So the script I was talking about, where I pull the data from production and push it up to my local, if I'm in MySQL shell, I just need to do \exclamation point and then the alias that I set up for that script, and it will do all that. It'll do all of that and show me the process and everything in MySQL shell. Yes, sir. I think so. I haven't tried that yet. I have something I need to try for the next time I give this talk. All right, this is the last bit that I'm going to talk about today. And again, having a tool with a help system probably isn't very hidden. But I think what the gem is how robust and how deep the help system goes for MySQL shell. So as you saw, there are a lot of global variables. So I gave examples where I use util dot, I use dba dot. Those are all top-level objects that are available inside of MySQL shell. There is help available for not only every object, but every method. There is help for SQL commands. There's help for data types. There's help for help. There's actually, I'm not lying, if you run the command \help, it tells you how to use the help. okay? It breaks down, you know, what the pattern should be when you want to go a couple of things nested to get help. It also tells you that, you know, you can actually have like a question mark or an asterisk to do some type of a like search in the help. It gives you the main categories. So we have the admin API, the shell command, shell API, SQL syntax, XDev API. You can actually get help about any one of those. It tells you about the individual topics. So it could be DBA global variables or DBA global objects. The MySQL X module. For people who don't know, the MySQL X module is what allows MySQL to use the XDev API to do document storage. So you can actually run a JSON document storage engine on top of MySQL, and it uses that MySQL X module. It talks about the shell API. Talks about other stuff in the API, all the available shell commands. Any word that is part of a SQL command. So anything you can think of that's part of a SQL command that isn't a name of something, you can get the help from MySQL shell. Oh yeah, and you can also get help on the individual commands in MySQL shell. So it's the connect, the disconnect, edit, exit, so forth. The global objects, so there's an audit, a check, a collation, config, DBA, demo, group application, heatwave utils, InnoDB, and you see the ... at the bottom there? That's because I couldn't fit all the stuff on one slide, but there's a crap ton of other stuff after this, after logs, that actually shows up when you do the / help. And again, it tells you for additional information on these global objects, you can do object.help or you can do help space object. And then lastly, it gives you examples of how you want to do it. So you can do /?, guess which one I use because it's less typing, to get stuff about the admin API, about the connect command, check instance configuration, SQL syntax. There is a drawback though. And I actually had a talk with somebody from the MySQL shell team a couple weeks ago about this. Sometimes it can be too much. I know it sounds weird, but trust me, sometimes the data you get back from the help system, the MySQL shell, can be overwhelming to the point where it's a pain to scroll back and actually look for what you're looking for, or find what you're looking for. And the example I use is, I do / dump schema. And almost any time you do help on something like this, it's going to break it down into the name, whatever it is that you're looking for, give you a description of what it does. It's going to give you an example of the syntax of how it would be used, and then it's going to, in this particular case, because it actually has arguments we're passing into it, it will break down what each of those individual arguments is supposed to be. And then it does this. That's a lot, okay? And trying to scroll back through that in a console is kind of hard to do. And I actually suggested that if we wanted to do dump utils and find what the option, what the different options are, that we should be able to do / dump schemas options. And it should only limit the output to what we want in terms of the options, rather than going and scrolling through that entire thing that we just saw. Yes, sir. Yes. I will also say that it's not as bad if you have paging turned on. I have paging turned off mostly because I don't like it. But I do know a lot of people that use it. So if you ran this command and you had paging turned on in MySQL shell, then you could actually go through page by page to find the information. But I just like the demo there where you just see all that information just fly by. Exactly. So those are the things that I think are exceptionally cool about MySQL shell. Everything else that it can do is still cool. I just don't think it's exceptionally cool. Or I couldn't fit into this talk with the other stuff that is exceptionally cool. So one thing you can do in shell is you can actually load external scripts. So if you have a .SQL file that has a bunch of inserts, maybe, I don't know, that was created by MySQL dump in another system, you can actually tell shell to run that SQL script against the instance you're connected to. You can create and manage clusters. So I showed one example of how you can actually create a read replica using MySQL shell, and very similar syntax and as much ease, really, you can actually create and manage MySQL clusters. So instead of just being a read replica, you actually have a cluster of data where if something happens to the primary, you can have one of the secondaries pop in and become the primary. And again, using sandboxes, you can test that very easily on your local machines before you spin up too many instances up in the cloud. You can export data in different formats. If you need an export of data that is stored in a table and the person who wants it as a CSV file, there's a command you can do. Export that and tell it what format to do. You could do tab delimited, comma delimited. I can't even remember. There's like 3 or 4 other formats that you can use that. It will dump the information to that table in that form. You can check the status of your MySQL connection. So when you're connected, you might know I'm connected or not connected, but it'll give you more information about how long the connection's been up, how fast the connection is, how much data's gone through the pipe and everything. You can actually integrate calling MySQL shell commands into another script. So there's a way you can actually format starting up MySQL shell, and this is what I use in that shortcut that I told you about, where in a shell script, I can say, in MySQL shell connected to this particular database, over SSH, by the way, because that's another thing you can do, run the command dump schema and dump this schema. The syntax is a little bit different than what you would do if you were actually in shell, but when you look at it and you see how everything's set up, it actually works it's pretty easy to figure out how to do once you see an example. You can also retrieve diagnostic information from an instance that you're connected to. It'll give you information about how many users are connected, how long the instance has been up and running. And I can't remember what else because there was so much stuff there. And also you can do customizations. You can customize how your prompt looks. You can actually write plugins so that when MySQL shell loads, you have additional information. You have additional functionality available to you, whether it's functions or something else. And you can also create startup scripts. I actually have a startup script in my instance of MySQL shell where I can just do C, because that's what I named it, .production, and it will run the connection script to connect to my production database. So I don't have to worry about remembering. Like I don't have to worry about remembering the IP address or the path to my private key so that I can connect through SSH. And then there's a lot more. There is so much in MySQL shell. Who here said they don't use, or who said they haven't used MySQL shell before? Okay, I hope you guys are going to give it a look. Because I'm going to be honest, I lived and died by the MySQL executable and MySQL dump and Workbench. But I haven't opened Workbench in probably a year. Because everything that I use Workbench for, I can do through shell, and it's actually a lot faster, even with my poor typing skills. So shell really it's really cool. There's also a plugin for VS Code that allows you to run a lot of these commands actually right inside of VS Code. It's a little bit of a different layout because it uses notebooks. But you have a lot of the same functionality, and you even have some more functionality because the VSC plugin allows you to set up connections through MySQL REST services, which is basically using your server as a REST point. So if anybody wants to reach me, my email is scott.strohs@oracle.com. I'm on Blue Sky @strohs.dev, Mastodon @strohs, and then LinkedIn is Scott-Strohs. I'm sorry they're not all the same, but the other stuff I wanted wasn't there for some of the systems. Does anybody have any questions? Any other questions, I should say? Yes, ma'am. Shell works with 5.7. Yes, I can't guarantee what functionality is going to work, but I know you can at least connect and run SQL commands against 5.7. What's that? Yes. You had a question? Oracle.com. you have my attention when you said I teach. Mm-hmm. I can neither confirm nor deny those rumors. I can neither confirm nor deny those rumors. Anybody else? Yes, ma'am. Mm-hmm. Yeah, so the question was, if you want to do an automated backup, can you use Shell to do that? Automated? Yes, you can, because you can actually use the, what I was talking about on the next to next last slide, when it was all, and all these other things. There is a certain syntax you can use inside of a batch script that will allow you to run backups, and then you basically schedule that batch script to run at a certain process. I actually have a process. So I manage a golf league. I've been managing the golf league for almost 15 years now, and I actually wrote a web application that allows me to manage it. There's 80 golfers who play every year. We play half on Tuesday, half on Thursday, and there's over 16,500 rounds of golf that's actually stored in the database. And I actually, the day that the always free tier of HeatWave MySQL was announced, I moved that database over to HeatWave MySQL. I had it on a compute instance with MySQL installed on the compute instance. And the bad thing, I didn't say that. The one thing that I'm not particularly fond of with HeatWave MySQL on the always free tier is the automated backups are only kept for a day, which I guess is okay, but I wish it was longer. But I actually have a process that runs on my web server that calls the OCI CLI to do a backup. So I run a backup of doing dump or doing dump schemas, and then I push that up to an OCI bucket. And then I have a process that runs that deletes, after like 60 days I delete it because I'm not going to delete anything beyond 60 days. But there is, and the documentation, not necessarily the help inside of MySQL Shell, but the documentation for using the CLI integration is really good. Where are you going? All right, no dolphin for you. Yes, sir. If you can execute commands in Python, yes. So basically, it'd be like you'd have to be able to execute the shell command. Yes, sir. So you basically you want to clone a table in the same schema or in a different schema? Clone a whole schema and then have it be in the same instance but a different name. Okay. So what you can do there is you could do dump schemas and specify the schema you want, and then when you load the schema, you can actually pass in the schema name that you want. So you can actually say, I want to dump the MySQL short schema, but then when you load it, make it Scott's really cool in that schema, because I am really cool. At least that's what I tell myself. Yeah, it'll and if you use multi-threaded, so like if you up the threads from 4, you'll see that it'll be even more performant than what it is by the default. What was that? Yeah, that you might be able to get away with not doing that, because if you remember when I did the upgrade check, there was errors about information that I had in that database. I have used dump and load on that database dozens of times, and those errors never caused me problems. It was only when I was trying to upgrade to a new version that it would have been a problem. So obviously, if you're copying a schema into the same instance, you don't have to worry about compatibility issues because the database already works because it's in the same version. Anybody else? All right, you guys are probably wondering. Oh, yes, sir. I don't know. I don't know if you're going to run into foreign key. I would imagine you probably would. So if you have a table that has, if you have a user type table, you probably want to bring in all the user types, and then just limit the users that are maybe used as the primary key or the foreign key. So if you have like reference data that uses a foreign key, you might want to pull it all in. So or you can change the where clause where you can say, I'm not certain this is going to work, but you could change the where clause to be like, where user last name starts with Z, and then where user type in, where user type ID equals, so you could do like you might be able to do a sub select in the where query, so you're only getting the foreign keys pulled in that were used in the main table to begin with. That may work. And I guarantee you before this weekend is over, I'm going to figure out if it does work. That's a good question, though. All right, so I'm sorry I'm running a little long, but you guys had good questions. I really appreciate that. As a speaker, there are few things that are more enjoyable than seeing somebody have the aha moment during your talk where you say something and somebody goes, I know how to use that. And I saw that a couple of times today, so thank you very much, because first of all, it tells me you were listening, and it tells me you were thinking about what I was talking about. And again, as a speaker, that is the biggest high you could get. So, in the beginning of the talk, I mentioned that I was going to ask a question about something you saw or something I said. It is now time for that question. And the question is, how much does Murphy weigh? Yes, sir. No. Yes, sir. No. Oh, my God. Yes, sir. 112. Thank you very much. This doesn't go far, so you'll have to come up and get it. Oh, went further than I thought. Anybody have any other questions? Thank you very much. Appreciate your time. I hope you guys got something out of it. And if anybody has any questions about anything, I will be here at the MySQL booth for the rest of the weekend. Thank you. You walk in, make a left. When you hit the wall, make a right, and then we're like the second or third booth on the right-hand side. Yep. Sure. Hold on.
Check 1. Check 1, 2. Check 1, 2. Test 1, 2.
Testing. Too loud. Testing. Yeah, much. Yeah. Testing, 1, 2, 3. Okay. Testing. Okay. Hello. Yeah. Thanks. Can you adjust this? It's okay. Okay. Testing, 1, 2, 3. Echo. All right. Welcome, everyone. So this talk is about leveling up your Grafana skills and including MySQL as well. But mostly we will talk about Grafana. And so let's get started. So a little about me. My name is Usman Ahmed, and I work in Grafana Labs as a senior developer advocate. And basically, I work closely with the open source community, either solving user problems on GitHub or Slack on our community forums. And yeah, beside that, I also have to perform the fun part, writing documentation and creating video content as well, or tutorials. And in my previous role, basically, I work with the industry for more than 15 years, and basically, I'm in the tech support area for Linux, so database was also a major part. Sometimes you have to check in the morning 50 GB of log files to see where is the error. Maybe the database is down or something bad happened. So yeah, that's a fun part as well, some old memories. Beside work, actually I come here all the way from Germany. Very excited to be here, first time at SCaLE. And I have a family, a small daughter, 4 years old. And yeah, and when I'm not working or as a hobby, I like to write. I like to create content, basically on Linux or any open source tool. And if you're interested, you can scan this QR code or visit my GitHub link to check all my work, which I done just for fun. Yeah. So let's get started. So today we're gonna talk about something interesting. Yeah, so I arrived today, or actually tomorrow, or yesterday, not tomorrow, yesterday from airport, and this is a good picture that when you are at the airport, you see a lot of people. Some people are rushing to their connecting flights, some are just waiting, some are angry as well, and some are confused. And our life is not much different what we see in this picture. Sometimes we stuck in a problem, trying to find a solution. Sometimes we are happy because we don't have any problems at all, but it doesn't work that way always. So basically, for a normal user, what are the challenges when working with a database? So the first problem is the collaboration. It is very hard to collaborate, to share the data, to work together because there are limited resources, limited channels, or basically, in other words, silos. Then we see performance issues. Basically, this is something very important when you work with customers and they report that it is taking too much time than expected for getting a query result, and you have to dig it. One interesting, which maybe people do not see much often, is how to see the results better, how to get the clear visual. It could be much better if you have a whole picture of it rather than just see everything black and white. Okay, and lastly, permissions. Permissions play a major part. If you don't have the right permissions, you will be stuck or just asking around like, can I get grant for more than just select, right? So you can do other operations, but yeah, these things happen. And most of these things can be summarized in this picture. Everyone loves pandas. They are very harmless, but you don't want to make a panda angry, right? And databases are like pandas. If you make them angry, you will be in trouble because the other people in your organization will ask you, what did you do wrong? You can delete a row or column or make some edits and things can go wild. So what is the solution for all these problems which we just saw in a database like MySQL? So how we can resolve this? So basically, we can use Grafana. Does anyone here uses Grafana? Raise your hand. Okay. And those who use Grafana, are we using version 9, 10, or 11? Okay. Interesting. This is always a great feedback for me to tell my managers, like, okay, we need to make this more, some more noise. Okay, so in a very nutshell, Grafana is just a visualization tool. Basically, you need to, if you want to visualize something, you can use Grafana, and it has various visualization formats included in it. You don't need to install it or configure it, it just comes in the package. And all it needs is a single source of data, a data which it can connect and start showing you in a visualization panel or dashboard. And this is more like a breakdown how you can understand better. So on top you have Grafana, and basically we call something plugins, and in plugins we have 3 different kinds: data sources, panels, and apps. Today we're going to talk about data source, and the one which we're going to see is the MySQL data source. So MySQL data source plugin is basically available in all Grafana versions. It supports various visualization formats, and it is very easy to set up and configure. You just do like any other, like host name, username, and password. And the cool thing is that this data source comes with a lot of features, which we're gonna see in demo. So I have prepared some small demos for you, so you can learn with very ease. It has query builder both in easy mode or code mode. It supports alerting, which is very vital nowadays. Everyone talks about a lot of data either running MySQL on local or maybe Docker or even Kubernetes, but you need alerting if something goes wrong. Similarly goes for logs. You need logs to check or debug the issue. We have Loki for that. It also supports annotation, transformation, and everyone's favorite, can it visualize time series or non-time series? Yes, it can. So how you can configure the data source? So it's just a 2-step process. You install the plugin or the data source from the plugin catalog and just configure it, and you will get a success that yes, it can, Grafana can connect to the data source. A data source basically where your MySQL server is. I don't know if you can see this picture much bigger or small. I try to make as big as possible. This is something which I got from our community users, that whenever they try to connect Grafana with MySQL, they create a user, which we here name as Grafana reader, but they give all the permissions. Should not do that. It's very evil. It will bite you back. You only need to provide select so that you can select the queries, not do any update, delete, or alter, right? It's the safe. So I highly recommend to only give limited permission, because at the end, you have the query mode in Grafana, so you don't want to mess around. And how is it going to work? So this is more like a high-level overview or how the request is sent. So you have Grafana and MySQL installed and configured. You send a query, maybe just select asterisk from a database table, and it will go to the database driver, which is written in Go. And if everything is fine, it will connect to the server. And if the server found the query valid and have the data, it will send the response in a raw data. This raw data will be converted in a specific data frames. And this data frame can be then readable by Grafana once it comes in JSON format. And this JSON format is definitely you use to visualize the data. Now we go in demo. So the first thing we will do is that let's start from the basic, how to create a dashboard panel. So basically, we have done the first two, right? And we will just use a basic query to see how we can use it, MySQL in Grafana. And we also play with some transformation, which we're gonna take a look a little bit later. Transformation is really powerful, so I will spend some more time to demo this. So let's get started. So basically, I have phmyadmin. I'm a very old user. Okay. Maybe if I can just drop this here. Yeah, much better. So I have this database called demo store. Can you help? Thank you. And it has two tables, product and sales. So in product, we have okay, I will just try to see if I can speak very slow and it works. We have products. You can see some data. I will just zoom in a little bit. Yeah, we have some entries, and similarly, we have a sales table. Okay. And in the sales table, we have a column called for timestamp, which says sales timestamp, and we have some entries like product ID, quantity, and the sales price. So this is a very interesting table. So how we can visualize this? So I have already set up some dashboard, but I will go through with basics. So this is our complete demo store of that table. And it looks pretty cool, right? You can do all this in Grafana, looks amazing. You can visualize all of this. So let's try to create one. So what I will do, I will just go and copy the query first, because limited time. I will discard all the changes, and yeah, now we start. So to create a panel, you go in Add, Visualization. And now you are in the query mode. And basically here you have two options. You can see the builder mode where you can select from this drop-down list what table you want to use, and it gives you all the options, even aggregations or alias. You can use this one, or if you are more like command user, you want to use the code mode, you just click the code mode and paste the query. And this is like select and the sales price from demo store, and we give a limit of 10. Run this, make sure to change it to the table format. Yeah, so table panel visualization, and run it. And now you see this data. And this looks good, but we can use some other visualization. So let's say stat, and now we see something like this. And what we can do further is that since this is the revenue, so we want to see this in currency, we have an option for a standard unit. And if I just type currency, I can select dollar or euro, whatever. So if I convert this in dollar, it looks something like this. And to make it more colorful, not red, green, just use the threshold. So yeah, this is very basic how you can create or visualize a query. And similarly, what we can do is create something like this. But for demo purpose, let's go beyond and see how we can do a time series visualization. So again, we have this pre-configured, and going in table in the code mode. Let me try to increase it. So when you're visualizing a time series data in Grafana, and specifically for MySQL, you have seen that we have this column for timestamp, and it is a valid timestamp data. But if you try to visualize it, it will not work. So basically, to make this work, you have to give this alias as time. Then Grafana will understand, okay, now I understand this column is basically a time. And once you do that, you can see all these graph with timestamp, like at which time, what was the sum price, and so on. Also, what you can do that is you can create annotations. So for example, you see this here, it is very low. So you just click it, add an annotation, and give like low or slow day. And add tags, strike. There was some public strike or whatever, and that's why there was revenue was not that much generated on that day on the store. So you can do that too. So this is pretty handy, and this is pretty useful in a way to visualize this. And yeah, you can use other visualization panels to view in bar chart or so, and depends on your SQL query. Okay, we have seen some of the basics, but let's go a little bit beyond. Now, we want to use transformation, and just as seen in the initial flow, that transformation are very powerful and they are handy. A use case of transformation will be something like, for example, you are a user, right? And you are not the database admin, and someone give you this query and say, hey, this is the query, make it work and modify it. But you say, hey, I do not have the permission or something, so how I can modify the right fields or the data which I'm looking for, or how I can change the field type. So this is where you can use Grafana transformations. Transformation basically are very powerful, and they're hard-coded. It happens before the visualization. And there are many types of transformation. Today, we're gonna see a demo of how you can use the two most important types. One is the organize, and then the convert fields. So again, demo time. Now, let's take an example of this GitHub performance data. So basically, this is a real data which I have taken from our Grafana official GitHub repo. And basically, this is how the raw data looks like. You have a title, author, company, repo, and so on. The important here is that you have this number, title, and close. Close is basically the state. It is closed, yes or no, and there are other more. So let's say that you want to filter this data in a way that you don't need unnecessary fields. So what you will do is that you go in Edit and click on Transformation, Add Transformation, and you type Organize. So it will come Organize field by name. And then you will see a big list of the same title which we have. And for example, title means description. And you can say number is GitHub issue ID, okay? And you can see that it is already changing. Also, what you can do is that naturally, when we view at these issues, we see first the ID and the description, not that the ID is at the last column. So you can move this up, and now you see that it is on the first place, and it makes you more readability, more convenience to read and view the data. Also, if you are not interested to see the author company, you can hide this. So you can do all these sort of things with Grafana transformation. So this is the one transformation which we see. Another transformation which we can use is called convert field type. So see this field which says close, basically it's the status. I didn't type all the field name due to time constraint, but let's see that this just says 0 means false, 1 means true, it is close or not. But 0 or 1, maybe you understand as a developer or the technical guy, but someone who is in HR or someone who is maybe know a little bit about the product and does not understand how you can do that. You select the field name and select the close one and set type to Boolean. And now it will show as false or true, depends on the state of the issue. Okay, yeah. So this is more about transformation. So we see the transformation are very good, but is there a way to enhance this data more better, more readable? You want to go to the next level. So I love Iron Man. It's a great movie. It's now old for some people, but I love it because it gives you this motivation that you can go beyond. Like when Tony Stark created the first suit, it was just metal, but he moves to the next level, which was amazing. And this is what you can also do. So we will now jump to a more detailed part, which is the panel configuration. Basically, we have done all this green box part. This is all checked. And we will dive into panel configuration to see some more features of Grafana, such as cell config, data links, value mapping, overrides, and so on. And we will use all this or look into it via demo. So override is basically just like transformation, except the difference is that transformation are hard-coded, override is just a layer of masking. It happens after the visualization, and transformation happens before the visualization. The cool thing about override is that transformation applies on the whole data set, while override lets you decide you want to apply to a specific series or even to the whole set. It's your choice, your customization option. So let's create or use the one which is known as cell type. So we have this picture, and you can see that the state, the close state of the GitHub, which says true or false, we want to make it more colorful, more readable, so that we have more visibility. How we can achieve this? So this is very easy. So what you need to do is that, again, taking this example, you go in Edit, and at the very bottom, you have an option called Add Field Override. And select field with name, okay? And then you select the field. This is the closed field. And then you select the cell type. And instead of auto, select colored background. And now, since Grafana is pretty intelligent itself, it automatically saves you time to color code it. It says, yeah, I understand false are red and true are green. And this looks more readable, more friendly, more eye-catching for someone who is looking at maybe an important issue or maybe looking at some specific KPIs of performance of your team or something. So yeah, this is very small but very unique and handy feature. So similarly, you can do cell type, and then you can do data links. Data links is basically in an easy way. So for example, I show you this case of GitHub data. So every GitHub ID is unique, and you can view it on the internet. Similarly, you have a product or something in your company, you are running a product, and you want to check of what's going on in this product, you have a product ID. So instead of manually copy-pasting this ID on the internet, why not make it dynamic, make it automatic? And for that, you can use data link. And all you need to use is that you again use the override and select the field for the data link and paste the URL. And just if you put at the very end this $, it will automatically pop up. So that's pretty easy. And what it will look like, all your URL will be linkable. So you don't need to go outside and manually copy paste the URL link. No, it's all inside in a single dashboard. It's all dynamic. And then we will jump to the next part, which is the value mapping. So value mapping is, again, it's very easy, but it's very convenient and powerful. So you have some data which you say like, okay, we have all the false, but nobody wants to say, yeah, that it's not close, it's false. Maybe you want to make it more nicer wording like, yeah, it's in progress or something, I'm working on it. So how you can do that? You can use value mapping. So anything which says false in that column becomes in progress. And similarly, we want to say that the value, which is basically the repo name Grafana/Grafana, we want to say Grafana-core, which is more easier for someone to understand, okay, this repo is only for Grafana core, not for the whole Grafana stack. And we can color code it. And once you do this, it will look something like this, that it changes the color here, basically, what we selected, and in progress. This here changed the text, but not the color, because it's a bug, which we just found out, but I just want to give it here as well. So to make sure that you get it, you can do more than just one color. It will get fixed, hopefully. So yeah. Now we talk to the most powerful part, which is called the dynamic dashboard variable. So in Grafana, we also call it as templating. Basically, imagine a use case that you have customers, right? And your customer may be using different data centers, like they are running AWS, GCP, different services, of course, but you want to see like how much of these customers are using these specific cloud services. Either you can create 5 or 10 dashboards for each service, or you can still create one dashboard but pull all these metrics in a single panel by using this dashboard variable. How you can do that? You use Grafana dashboard variable. And there are many categories of dashboard variable. You can use data source, custom, even a text box. But today we're going to take a look at the query one. Query means like you select the MySQL query, you have a query specific, you get all the data, and then use it. You already get the idea, okay, if my query gets updated, yes, the value will also get updated. So that is very efficient. So for a quick demo, I have already one from our player dashboard. So this is a very similar IMDb looking dashboard. And here we have a variable named film name. And it says all. And if I select something else, I hope it works. Yeah, okay, it get updated. So it select which, according to the variable, the value or the data for that particular movie. If I select something else, it will get updated. But this looks nice how the internal looks like. So just click on Edit, Settings, and Variables. And here we have this film variable. Okay? And basically, we define the query from the MySQL query data source, and here is our query. So select title from film list, okay? And we already get all these options. You can use multi-value, you can use all, it depends. These are the default options, which is fine. And what's going on is that if we take a look at this panel, basically, here we are using this variable that where the title is film. So instead of creating a whole 500 dashboard for just movie database, you can just use one single variable and you can get all of this. And this use case apply if you have multiple customers running multiple services, or you're looking at a specific KPIs or performance reports where you need to just change based on the team data or specific user data. You can get all those kind of metrics. So yeah. Moving forward. So we have seen some amazing features, which is good, but we can even go beyond the next level. We can go up to max, up to 100. And yeah, again, taking an example of Iron movie, that how you can improve your current Iron Man suit to perform better, have more artillery in your arsenal, and things like that. So alerting is a very important part nowadays because everyone wants to get an alert when something goes wrong. You don't want to sit in and see that, oh, I will just keep querying manually or maybe create a shell script and it will send the data after connecting to the service. You want something more direct, more easy. And everyone needs alert. Either they are good alert, bad alert, or something unknown, where you don't maybe getting the right data. You still need an alert for that. And Grafana makes it more easier. We provide all these features in a single place so that your life can become easier. So alerting is very simple. We have worked on alerting component a lot, and basically we have provided many contact points. Contact point means like you can send alert to via email, to Slack, and so on, which we'll see in a demo. and you can incorporate this alert solution in a more incident response management as well. The alerting basics looks something like this, that it's a cycle that you create an alert, you create an alert. Once it gets detected, you work on it, fix it, and learn it that how we can not, it should not be happening again. But it's a cycle, it's a continuous cycle, which is sometimes vicious as well if things go wrong. And this is in more detail how alerting works. So you have a normal alert, and you set a condition, right? And if the condition is pending, it will evaluate that, okay, if it matches that particular threshold. If not, then it will remain normal. But if it matches, then you will fire an alert. And once alert is fired, then you will get a notification, but once it also gets resolved, you also get a notification that it is resolved. So you have to work on this in a way that you can get all this data in a correct way without making a lot of alerts or even just less alert. Again, it depends how you want to configure it or how your data looks like. So now we talk about a little bit more on notification. So you want to send notification to a group of user or an individual user. So you can do that in Grafana. We have an alert manager. And again, you can just create alert notification for a single MySQL server or multiple. It depends on your choice. So you define this notification policies. You can group them. What means by grouping? Suppose you have 5 to 10, just 5 to 10 queries which are very vital for your organization to get notification alerts. You don't want to send these 5 alerts individually. You want to group them in a way that you get to the right person in the right way rather than firing 5 to 10 alerts every time. So you can group them as well. And you can group them and send it via these, either on Slack or email, you name it. And you can also route it as well, which we'll see now. So routing these policies means that as a route, if you have an alert which is labeled as something for team security, it will go to the security team. But if it is labeled as for team for the backend, it should go to the backend. This is Grafana. Grafana can do that. You can label your alerts so that each alert goes to the right team without all the noise, because we don't need noise in alerts. We want meaningful data. So demo time. So I will go here and alert. Yeah, alerting. So I have already created one alert which says firing, which you can see here. Basically how it looks like. So basically you create a basic alert rule, give it a name. I name it as high usage, and I select the MySQL data source. And this is my query that which count all the variable name from a table called my2.status. And then I define a threshold. And I say that input of A. A basically means this. This is A here. This is the query A. Then I deleted the query B because I don't need it. You can do that too. And I just need the C so that, say, if A is above 70,000, it should generate an alert. And let's preview it. This is the current value, which is higher than the expected one. And that is why it is firing. So this is the concept of alerting, and I can show you in my Slack. I'm receiving all the alerts on Slack. Yeah, here it is. So this is how the alert looks like. And I will click show more. And basically you see all these data, labels, name, folder, which we can see here. So if we go down a little bit, this is our alert folder name. You need to define a folder. And here exactly what we just saw to create labels. You can create as many labels as you like by simply edit labels and maybe add one more if you like. And with this label, you can decide, so should this alert be sent to Slack or to who is the contact point? Is it for the back-end team? Is it for the front-end team? Or is it for the security team? And one important part is also this evaluation. So as we see in the previously, that you don't want to send alert immediately. You want to wait. Maybe there is a small network glitch. So you need to define a pending time. Maybe you need to send alert after it is happening, after still 5 to 10 minutes. Yes, maybe send an alert. You don't want to send it immediately. For the demo case, I just set to none. So anything which is above that value will immediately fire on Slack. And yeah, and this is my server alerts I'm sending to Slack. But I can select also email if I want to. Again, it's your choice, your alert, your rules. And what more interesting is that you can define a custom notification message. So I say in summary, like, hey, this is my alert, description, you can provide more. And this runbook. Runbooks are very important when it comes to alerting. I have worked with, I told in tech support, when these alert comes, they are just noise. But with this runbook, these details, you know who to contact, who's the account manager, who is the right team, who is the product owner. And you can add all these details as annotation inside Grafana by using this UI. You don't need to customize or use any fancy tool. It's all here. And you can see all this data here as well in the annotation, right? This is just demo, so it's just google.com, but yeah, I mean, in real case, it will be something different. And yeah, similarly, like alert, the next part is logs. So we have a saying, like, customer may lie, but logs don't lie, okay? Because customers say, like, hey, something bad happened, I didn't do anything. But if you check the logs, you see, like, hey, you did this. You roll out the wrong patch, or you did update incorrectly as we provide instruction, you didn't do that. So logs are very important when it comes to MySQL. Because in MySQL, you have different kind of logs. You can debug this. You can maybe processing slow query logs or maybe binary logs. There are many kind of logs, depends on your use case. And you can visualize all this log in a single platform. Because if you don't do it, it's very challenging. It will take a lot of time for your team, for yourself to analyze and find the right cause. And Grafana provides a tool called Loki, which can do all of this. And it helps your team to work efficiently, save time, and visualize almost anything. So yeah, basically Loki can take all of it. It can visualize all sort of logs. Either it's you are running MySQL on Linux, or maybe on a Docker or Kubernetes container. It doesn't matter. It can visualize anything. And you can use Loki with any of these. You probably see some familiar names like Logstash, FluentBit, or FluentD. Or you can use with Grafana own tool, which is known as Promptail. It's an agent, and Grafana Alloy. I would highly recommend that you should use Grafana Alloy from now on, because Grafana Promptail will be like March next year, will be end of life. It's already in maintenance mode, and Grafana Alloy is the feature, because Grafana Alloy makes sense. It is built on open telemetry standards. It can collect all the telemetry data, including for logs, Loki, and you can also combine with other tools as well. How does the Grafana log work in a high level? You have your application, right? Yeah, you have your application, and you can use any agent, Grafana Alloy, Promptail, or something other, or even just use REST API, and Loki will see these logs coming and will forward it to Grafana. And you can also create alert using Prometheus or your own logs alert, or even correlated, like when we talk about the 3 pillars of observability, like logs, metrics, and traces, and correlate them. You can do that, but that's a little bit beyond this talk for today. Yeah, it needs own talk. And how does the Loki indexing work? So basically, we have this data, right? You have a timestamp, You have the labels and then some context. So what Loki does, it does not store the whole data. It just stores the index. So what happens is that your 10 TB of logs will only become 3 TB because Loki only need to index 50 MB of data. So this is, again, a very powerful feature to save your disk space because logs will continuously grow. You may go in debug mode, or you have to keep that for data retention policies, you have to keep the customer logs for the next 2 years or 3 years, depends on your policy. And Loki can definitely help there as well. And again, it can get logs from anything. It doesn't matter that it will be only Linux or Kubernetes or Docker, anything. So for logs, we have an application called Explore Logs. Basically, this is something very new. It has given a new name called Drill Down Apps. Basically, you can visualize logs on the fly. You don't need to create even a dashboard. So how it is look like, let me show you. I just need to connect to my machine. Yeah. Okay. So you are in Grafana and you go in Explore, right? Oh, Explore. You see, yeah, okay. So you expand this and you have see metrics and logs and profiles. If you just click logs, you will start to see all the logs already. And you don't need to rocket science and do this. You can use Explore as well if you want to create logs. I will just show you a very small demo. I think we are good on time. So you select the Loki data source and you can say like, hey, anything service is equal to production. I want to see logs. Let's run it. Yeah, we get some logs. So you can use this or you can use that if you want to just get a quick overview what the system logs looks like. Maybe there are so many errors or anything which is looking fishy or warning. So yeah. So same what's new in metrics. We have worked last 2 years a lot on the metrics side as well. And basically in metrics, yeah, we use Prometheus to get all the metrics. And this is a standard picture. I didn't create it. I just steal it from the internet because everyone uses the same picture because this Prometheus architecture. But what I want to highlight is that this is Prometheus server. It has its own database. And you can use any sort of exporters like Node Exporter or which I use, and also MySQL. But once you use this, use that, Prometheus will get all the data. It will pull the metrics, and you can either send this data to any of the alert manager services, like you get notification or PagerDuty or email. Or you can just use Grafana, which we just saw that Grafana can also do that. You don't need to find a new separate stack to get all this. Grafana has all these functionality available, even in alerting. And this is what I am using. So basically, I have even just one MySQL server, but if you want, you can monitor more than one. And I have set up Node Exporter and MySQL Exporter. And Prometheus get all these metrics, and Grafana helps me to visualize this by pulling these matrices. And for demo, again, we can use Explore metrics as well, just like we just saw in Explore logs. So the demo will be something like this. You are in, you go in Explore and just click metrics. You click Start Visualization. And now you have all the complete overview of your data, okay? You can select for MySQL, because I'm using MySQL Exporter as well, so you can get all the information, for example, for your InnoDB or table, depends on your configuration, what you have set up. One other way is also that if you want to visualize not this, but create a dashboard, you can do that. So I have MySQL Overview Dashboard, I believe this is the right one. Yeah, so you can create dashboard as well, using these exporters to get the right data. And this can help you to find any performance issues or something, you can even use this dashboard to create alerts. So anything which is maybe if the MySQL query per second is very low or very high, you can create an alert. But for first part is that you need a dashboard. So this is again very powerful feature which some people say like, hey, we are just more interested in the MySQL part. No, you can use all these metrics to get MySQL internal information as well. So we come to the last part, which is private data source connect. So everything which I have spoken in this room sounds very interesting, very unique, and definitely make case. But probably some of you will say, hey, the problem is that this is all good, but the database server in my company is remain internal. It's not publicly available, which makes sense. So you don't want to expose your database server outside on the internet because, yeah, it's bad. So you don't want that. And even if I suggest, hey, you can use Grafana Cloud because if you want to use free service, we have a Grafana free cloud account, which is free forever, basically, and it's very good to get some amount of data and visualize anything. But that's also a bad solution because you will have to allow incoming port so that you will expose your firewall for that, and it's not idle. Your IT team will say no go. So how to find a solution for this so that your data can be remain outside as well or can be available outside to the public internet without any harm? So we have a tool called Private Data Source Connect, PDC. Basically what it allows is that you use Grafana Cloud. Grafana Cloud comes with the PDCV service out of the box. You don't need to install anything. And on your network, you install a PDC agent. You can install this, and what it will do is that it will create a secure encrypted socket channel, which allows you to send the traffic and also receive it, and you can query your databases. You can use other data sources as well, but since we are talking specifically for MySQL, it also supports that as well. The key feature or advantage of PDC is that you can install this on using binary or directly on your Docker machine, or if you're running on Kubernetes, you can do that too. Data is completely encrypted, and it supports many data sources, MySQL, Prometheus, some Azure as well. On the documentation page, there is a big list, so which we'll see later. So yeah, it is something which our customer asked, that how we can make secure, find a way of secure way to send these query on the internet, on the cloud. PDC is the solution. So how you have learned all these cool things, which may be something new for you. So how you want to assemble your stack. So basically, at the top, you have this visualization, but you use some sort of like a data source. We call it Big Tent or open source data sources, which we have here. And this is your environment, which it connects to. And you use maybe some sort of an agent, which could be something like Grafana PDC, or maybe using other tools like Prometheus, FluentBit, or even OpenTelemetry. And then you have this configuration, this stack, this LGTM, low-key for logs, Grafana for visualization, Tempo is for traces, and Mimir is for metrics. And you can even use Pyroscope for profiling. Profiling is an important topic nowadays as well. You want to see like how much, what kind of library is called by your application, and you want to see those metrics. And you can add more layer of observability by, for example, if you want, you can use K6, this one for performance testing or load testing. You can add Faro for front-end observability. You can use eBPF Bela for any kernel calls or system calls. Similarly goes for infrastructure, and we see the alerting part, which is called the IRM stack, which is the whole package. So yeah, you can use all of this as open source as you like and create your own stack. So community is very important part. This is all big help from the community, which that's why I am presenting this topic, and some even use cases. And like 3 pillars of observability, we called the 3 pillars of community. For reporting any issue, use our GitHub. If you want to ask some questions or even help others or do both, you can use Slack and community forums. I highly recommend to join our community forum because they are very powerful. We have some engineers who provide a lot of solutions. Even I'm sometimes there, depends on the time. But I love being part of the community, it's amazing. And yeah, so the final takeaways will be for this presentation is that when you use Grafana with MySQL, it gives you more enhanced experience. We have seen, for example, that GitHub data, that it looks all basic. You have the power to use transformation, you can use overrides, value mapping, and so on. And it has a lot of built-in integrated features. So we see that you can use alerting, you can use logging, and you can use more beyond it because the database is just the part. It depends on the application. If you want to use maybe your application is need front-end observability, you can use Faro as well. But at the same time, you can use Grafana as well. Oh, sorry, MySQL. And one more example of this built-in integration feature is Prometheus, of course. Prometheus is also a data source which you need to connect, but it provides a lot of features to visualize all these data. And the last but not least is the community. Our community, I think we have more than 13,000 users on Slack only, and around 45K users on community forums. So you can see that we have a wide, massive range of community users who are using Grafana, and obviously most of them also use MySQL. So you will get all the support to get started, even to ask, get help, and maybe you can help others by providing your own solution or use cases. This is all about community. And yeah, last but not least, we have a booth here where you can visit us, get all the cool swags, and also happy to answer your question. I will be there as well, but tomorrow will be on official way because tomorrow is my booth duty. So yeah, visit our booth. We are friendly people. We like to talk to you. You can share your experience. Any kind of feedback, we welcome it. And with that, I'm about to end, but before end, you can scan this QR code. You can get all the details, all the links which I have used in this presentation. So it can help you. And if you have any question, you can contact me via email or just even LinkedIn me if you are interested to hear more or maybe have some way to collaborate, because we want to see if you have something to share, maybe we can help together to write an article and we can publish it on Grafana site. And yeah, you name it. Yeah, we have actually recently did this for some community users who want to share their experience maybe with MySQL or Postgres or whatever. Yeah, so that's all. Any questions? Okay, yeah, or, okay. Okay, well, thank you very much. Oh, yeah, sorry, you have? Yeah. Okay. So that's a very good question. So basically, the question is that some companies may use Prometheus, but some not. So depends on on the use case, what will happen or what you need to work on the homework on your side. So basically, it is not mandatory to use Prometheus with Grafana, which is a very common use case, or someone understand, oh, Prometheus and Grafana works together. Yes, it works, but for example, today I just show you all this about MySQL data source, not Prometheus data source. Yes, I use Prometheus to pull metrics, but you can use InfluxDB and Telegraph together to get all these metrics. The only, there's no downside. I think the only thing is that you probably need to work a little bit on it to find some ready-made solution. There are actually existing solutions as well on the Influx DB side, and they have improved it. I think what will not happen, what we have seen today in the slide, is that the explore metrics and explore logs, like the logs and metrics coming on the fly, that is something only possible right now with Prometheus data source. If you use Influx or maybe some other data source, you will probably not see that. But other than that, it's your choice what you want to use. There is no limitation, because your company probably did some benchmarking, like, okay, it makes sense to use Telegraph or Influx rather than Prometheus, it's fine. So you can find multiple roads, but only that explore logs and metrics is not available in that case. But still, you can use basic logs like Loki with Grafana Alloy. You can still create logs on your own rather than expecting that it will be auto-generated. Any other question? Okay, thank you everyone. Thank you for being here.
Testing. Testing.
Turn it off, you just hold.
Testing. 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 Yep.
Sound check. Yeah, we have 1 minute. Usually the mornings were worse, now it's the other way. What? No.
Hi, everyone. I just want to read a quick word for today's sponsor, Foglight. When your MySQL database slows down, is it queries, indexing, replication, or something else? Foglight gives you full visibility into what's causing issues so you can fix them fast. And Toad helps you optimize queries with automation and best practices. If you ever lost hours debugging slowdown, you need these tools. Let's chat after.
Thank you. Thank you, everyone, for joining this session about lessons learned when managing MySQL in the cloud. My name is Igor, and I'm working as a principal consultant at PTN in the open source database practice, in the MySQL and Mongo practice. I have a master's degree in software engineering and been working with computers for almost 20 years now. I'm a MongoDB certified DBA working with MySQL Oracle version since 2008 and also MariaDB since it was founded. Terraform Associate certified and GCP professional architect. My expertise is Bash, Python automation, working in hybrid clouds. I'm a husband and a father. I do like to travel, and I also speak at conferences maybe 2 or 3 times a year. On social, I'm mostly active on the X platform and LinkedIn. About the session today, this is about my personal hands-on experience managing MySQL in the cloud. I don't have GenAI content in my slides, except if you see some of the emojis as they are. I used some GenAI to actually generate or regenerate those, so, but there is no content generated with GenAI. This is cloud-focused session. It does apply to MySQL managed on-premises or MySQL managed on VMs in the cloud, but primarily I'll be speaking about database as a service. And this is not a training session, so you should not expect that this is a training for MySQL in the cloud. It should be a beginner-friendly session. We will be discussing about the cloud, benefits of the cloud, configuring MySQL, installation, automation, version controls, upgrades, performance, cost-effective scalability, high availability, disaster recovery, monitoring, and security. So we'll have some time for Q&A at the end. First, some of the benefits of cloud adoption. Why would you even want to go to the cloud, move from on-premises? Well, first, it has a lot of automation that you can build around your deployments of your infrastructure. It provides a much easier scalability, so you can scale resources up and down very easily. Cost efficiency, this is debatable, but if you know what you're doing, then it should allow you to be efficient with your costs. It's very easy to collaborate in the cloud, so different teams can collaborate across multiple projects. But maybe most importantly, the clouds are where all the innovation happens. Every year there are different products that many clouds just innovate and share in the community. It comes with default security and compliance. So if you are running your systems and services in the cloud, there are some defaults that the cloud is already compliant with, and so you will be also compliant for security. And by native, the clouds are designed for resilience and disaster recovery. Infrastructure as code in the cloud, this is what allows you to actually declare your infrastructure. So this is one of the benefits and how you can automate your infrastructure. You basically declare your infrastructure as code, and this allows you to eliminate human errors. Every time you want to create your infrastructure, you will create it the same and eliminating human errors. So there are tools that you can use to declare your infrastructure as code, like Terraform or OpenTofu. Every cloud has their own cloud formation or cloud development kit where you can use their code to declare your infrastructure. For example, for Kubernetes, you can use Helm. Also, you can use Ansible, Chef, or Puppet to install and configure your servers. And there is also a feature for reverse engineering. Once you have your infrastructure running and you have created the infrastructure, you can reverse engineer your infrastructure to be created as a code. So later on, you can use that code in case of a disaster recovery, so you can recreate the same infrastructure. This is just one example how creating a VM would look like if you have a provider AWS or provider Google. Then you can just use this code and it will always create the same instance. So a human may make a mistake by creating the VM in different ways, but with this, it always creates the same. The way how you declare it, that's how it gets created. The difference this talk is mostly focused on cloud, managing MySQL in the cloud, but there are some things that would be the same managing MySQL even on premises. And if you go managing MySQL on premises, you get the flexibility. You can choose what's your power supply, what is your network card, the operating system installation, what database version you want to install, what instance type, and so on and so forth. So the flexibility is there, but at the same time, there is the management overhead. So you need to worry about operating system patching. You need to look for expertise about all these steps that will be required in your architecture maintenance and software life cycles. So for one example is also that by default you don't have high availability. So all these you need to think on your own. If you go and use the cloud, you still have option to use MySQL on a VM. So this is showing Amazon EC2, but it would be the same in any cloud, even GCP or Azure or OCI. This is just a VM. So some of the operational burden is taken from you. You don't have to worry about hardware lifecycle. You don't have to worry about server maintenance, operating system installation. You just create the instance, and then above that, there are steps that are still on your to-do list, like the database software installation, patching, high availability scaling. That is still for your team and on your to-do list. Database as a service takes a lot of that, so you can focus only on the application optimization, and with this comes the database optimization. So the schema design, everything that comes with the database optimization, that is still something that your team will do, but scaling, high availability, backups, all that is managed and it comes as a service. But even with this, there are still a lot of things that you need to take care of, and this is what we will continue looking at. Provisioning database as a service is still a process that involves planning, and there is a lot to choose from. Things like whether the instance that you're provisioning is for production, is it for development, for testing. There is also a free tier that comes with most clouds, so you can just experiment. For high availability, there is option for multi-AZ deployment, so your instance will be running in, there will be a standby instance in different availability zone, which implies on cost. So if you want to be highly available and have a standby, then you will paying double price. So that is expected. The storage is auto-scaling, and there is option to, when provisioning the instance, you can choose to auto-scale the storage. With Amazon Aurora, this comes by default. And in GCP, there are database flex, which are basically my.cnf variables, which in AWS are called parameter groups. So everything that you want to modify on a database in my.cnf, in AWS is called parameter groups, in GCP it's called flex, and you can override any flex. It also it's important to think when creating instance, whether this will be your primary instance, or if you are declaring your infrastructure as code, whether that would be a secondary. How you would migrate the data. There are multiple options like database migration service, or just using logical backup or extra backup, for example. In some cases, the small instance sizes don't have performance insights, like in AWS or in GCP Query Insights. So small instance sizes might not have this feature, but some instance classes and sizes will have this feature enabled, and it's a free tier for 7 days by default. So if this feature is enabled for your instance, I recommend it. It's helpful for observability. And by default, there is a backup which comes from 7 to maybe up to 35 days with no extra cost. So this is also one of the features in the cloud that you don't pay extra, but you get as a feature, and it's fully automated with point-in-time recovery. For high availability, if your instance is for production, then you probably would like to create a highly available solution. AWS offers now 2 options for high availability. In the left example, this is multi-AZ deployment, where there is a single active primary instance, and there is a standby instance. Your application will only speak to the primary instance. It cannot connect to the standby. But there is also an option to create a multi-AZ cluster. In a multi-AZ cluster, the primary instance is where your write traffic is redirected, and the standby instances are 2 replicas that are also reachable, so your application can also talk to the standbys. So you actually pay for the standbys, but you can use the standbys by the application. Sorry. GCP offers about the same. In GCP, there is a primary instance, and there is a standby instance that the standby instance you cannot use from your application. You need to create a read replica if you want to redirect some of your read workload to a read replica. And this is pretty much the same even if you go to Azure. Azure has about the same configuration for high availability and multi-AZ deployment. For cost efficiency, when you are deploying your instances, if you just deploy and keep running on demand, there will be a price that might work for you. It might be just fine, but if you know that you are using the instances for a longer period of time, you can commit, and there are different discounts. In this example for GCP and AWS, if you commit to use the instance for 1 year, the discount is between 25 and 30%. If you commit to 3 years, then the discount might be between 35 and maybe even 60% discount. So this is really important, especially for cost efficiency, and if you want to reduce your cloud bill. If you know that your instance will be there and you will be using it, probably better to just commit and use the discount from committed usage. And in these prices, storage and I/O is not included, so that is a separate expense in the monthly bill. One important thing when provisioning MySQL, even on premises, on VM or database as a service, is that you need to have my.cnf with all the parameters that are important for your environment, as not all environments will be the same, especially when it comes to different instance size. If you are on premises or on VM, you will need to take care about the proper sizing of the buffers, threading, per session variables, and so on and so forth. The cloud, especially database as a service, will have that figured out for you. So there is a default parameter group that comes pre-configured for every instance size. But the important thing to mention here is that if you want to change any of the parameters later on, you cannot modify the default parameter group. So when creating the instance for the first time, when provisioning, it's recommended that you copy the default, create it as a custom parameter group, even if you do no, zero changes, apply a custom parameter group to the instance. So later on, if you want to modify anything, then you should be able to modify your custom parameter group. And one of the things when you have a multi-tier replication or is just a replication with different reader pools, there is an option to actually specify different parameter group per environment. So in this case, if you have a reader pool, let's say that is for analytics, in the entire reader pool you can apply analytics, a custom parameter group. So later on, if you want to just modify the analytics instance classes with anything that is custom just for those 3 instances, for example, you can just modify that custom parameter group and not touching anything else. If all of the instances here are using just one parameter group, then modifying the source for whatever reason will just push the same changes to the entire group. So something to look at, especially for multi-tiered and environments that you have different groups of instances. Before going to the cloud, in most cases you may have a database that is on premises or it's on a VM elsewhere. So usually what happens is you create an instance in the cloud and you want to migrate your data to the cloud. And in this example, I'm showing a migration from any source to a cloud database as a service. And there are different tools. Every cloud has a database migration service. With the database migration service, you should be able to even migrate data from a different database type like Oracle or MS SQL to MySQL. So the data migration service will allow you to match the data type, maybe even suggest migration of your functions, store procedures, triggers, anything that might come with the different language between the different database types. As well as the MySQL Workbench has similar features, but the data migration service in most of the clouds is more specialized to do complex migrations. Other options are taking extra backup on a MySQL database. AWS works with restoring RDS instance from extra backup that is on S3, for example. Additional options, logical backups like MyDumper. It's a multi-threaded logical backup tool. One thing that we ran with MyDumper in the past was that when MySQL has a JSON column type, there were some issues migrating the tables with JSON column type. So I don't really know if that's fixed yet. But MySQL dump will always work. It's the slowest option to choose because it's single-threaded and it takes really long for large data sets. But for smaller data sets, it works just fine. And the newest option is the MySQL shell. MySQL shell is also a logical backup tool, but it's multi-threaded and it works really fast for backups and restores. One thing to look at before doing database migration is that you create a custom parameter group, and if you have store procedures in your database, you would need to enable the logbin trust function creators variable to on, so that you in the cloud you would be able to import store procedures. Some of the privileges, especially database as a service, are not allowed. So you need to be careful if for some reason your application is dependent on any of these privileges and you need to create a user. You would not be able to grant the super privilege or let's say the system variables admin, the file privilege, and there are extra privileges that are not allowed in the cloud. Before doing the migration, obviously, you just want to choose the same instance size as you already have your MySQL running. So if you have MySQL running on a VM or a physical machine that has 500 gigabytes memory with 64 core CPU and 3 terabytes of disk, then you should match about the same instance size. So maybe the cloud will not have exactly what you're running, but there should be something really similar, and especially the network bandwidth that comes with that instance size. One personal experience is that if you configure a production environment, you would probably go with multi-AZ deployment because you want high availability for your production system. But if you are just doing the migration, initially skip the multi-AZ because you will wait longer to import the data as the data is inserted into your instance, and on the back end is copying that data to the high availability instance. So you will wait longer unnecessarily. You can create the instance initially as just not multi-AZ, import the data, and after that you can modify the instance and make it multi-AZ so you have the high availability. And it's important that you match the database minor version between the two. What you're having from the source, you want to match that same minor version on the target. As mentioned, creating the instance, backups and performance insights are usually enabled with 7 days retention and for free, so utilize. Creating the instance has a maintenance window for auto minor version upgrades. And probably that is not the greatest idea to just enable minor version upgrades, and each time a new minor version comes out, your database will just apply the minor version, which just might cause you unplanned downtime if the instance gets restarted with no planning. And a lot of the automation in the cloud has a deletion protection. So if you don't want anyone by accident to delete your instance, then there is a checkbox to say deletion protection. And unless you modify the instance to uncheck that, you can't actually delete it. I have one example here for logical backup migration with the MySQL shell, and this is proved to work. I have used it a lot, and it's just a single command. If you look at it, MySQL shell, you specify the URI for the source. In this case, my source is a GCP endpoint. And then, once you are connected to the shell, you just issue the command copy instance. And the copy instance, there is a parameter for where to copy. And this is the RDS endpoint. And there are some additional options in MySQL shell that you can use. Running dry run at the end will give you all the steps. It will not execute the command, but it will give you all the steps that it will do. So if you see that something is warning or error, you can work back and fix it. Sometimes it might not be a good idea to import the users because there might be differences between what you have in your user grants and what is allowed to create, especially on a database as a service. But there is a workaround on that, so you can use PT show grants, for example, and with PT show grants you can create a SQL file that has the users, and later you can just edit the file, remove all the grants that are not compatible with the database as a service, and you can import. And even if you don't, importing this into a database will stop at the user with the error. You can fix that and import again. So for application, you are on premises or already in the cloud or between databases as a service. In the cloud, running this change master to master host, master username before MySQL 8.4 or after 8.4, this is change replication source. In the cloud, this will not work. What works in the cloud is that you need to call a special function that in AWS, for example, this would be call MySQL RDS set external master. And then in this command, you will execute the actual host name, port, replication username, and so on. Then you execute another function, RDS set external source GTID purged, to tell this server what is the set of GTIDs that are already purged. Then run a command with auto position, so it will auto position the GTID and call start replication. So all these are functions, and it's not allowed to actually execute change master like on a self-managed MySQL. GCP has about the same, except that in GCP it's not functions, it's calling APIs. And once your source and target instances are up in sync, at the end you can reset your target and just run a function RDS reset external master, and from there on that instance is basically acting as a standalone instance. You can point the applications to that instance, and from there on you don't need to use that, but you can just run a click and create a replica set. And it's that easy to use the automation in the cloud. It will create a replica. It will create replication users for yourself. It will create the instance, and once the instance is ready, then you should be able to just utilize that instance. If you want to switch from RDS to Aurora, there is also automation on that. On an existing instance, you can just create Aurora read replica. The Aurora read replica will be created once the read replica is in sync and you stop your applications with writes. You can promote Aurora to become a standalone, and from there on, you can just point your apps to connect to Aurora, and you migrate your workloads from RDS to Aurora. Major version upgrades. This is example of upgrading from MySQL 5.7 to 8, but it would be pretty much the same for upgrading from 8.0 to 8.4. One of the things that, while working on major version upgrades, we discovered is that sometimes this may fail even if there is automation about database version upgrades. For example, if you're upgrading from 5.7 to 8 and 5.7 is not on your latest minor version, then upgrading to 8 might fail. So you first need to bring your 5.7 from 5.7 previous to 5.7 latest minor, and from there you need to upgrade to 8. Probably it will be the same for upgrading from 8.0 to 8.4. Additional failure might cause that your 5.7 instance is not using current instance class. And if not using current instance class or the next generation instance class, your upgrade might just fail. So this is something that is not straightforward when working with version upgrades, but especially in AWS, they have this covered in their documentation that only current and next generation classes are supported for running database as a service. And upgrades might fail also if you have a custom parameter group. And in that custom parameter group, you are using some variables that are necessary for your database, and you use those features for your application. And if you don't create those for the next database version, that also might cause you a failure in your upgrade. The way how you would usually upgrade is mostly the same as you would in on-premises or running MySQL on a VM. You can take a snapshot of your lower version, restore that snapshot in a test instance, and perform the upgrade on a test instance. Once you validate the upgrade and once you verify, in production, usually you want to upgrade from the bottom to from the secondaries to the primary. So one of the secondaries is the first candidate to upgrade. Once you validate the application that it doesn't throw any errors with the next major version, then you can cycle all the secondaries and at the end upgrade the primary. You can do the same with the feature of blue-green deployments. This is something that exists in AWS, and it's not new in the software development. So the blue or the current environment is where your existing infrastructure is, and you just create a green environment that is called as a staging environment. AWS in the background will clone the blue environment, it will create green environment, and the green environment will be replicating from the blue environment. You can connect separately to the green environment, do all sorts of application testing, and once you're happy, you can promote your green environment, so that will be your active environment. This, however, might cause failures, as it's not a failback secured. If you want to go back to the blue environment, there is no mechanism to allow you that. It doesn't provide failback option by default. So for that, the extra step that you would like to take is, once there is a blue environment and once there is a green environment, when you promote the green environment, AWS will show you what is the binary log file and position at the time of the promotion. With that, you can create a replication user on the new primary environment, and with the binary log file and position, you can point the blue environment to replicate from the green environment. And with that, you can keep the blue environment up to date with all the changes that now your database will be capturing from the application. And if you do want to fail back, then you can just stop your application, get rid of the green environment, and point your application back to the blue environment, because the replication will allow you to do that. The blue will be in sync. Something else that we often do with managed databases or even database as a service, but this is a useful toolkit for everyone, the Percona toolkit. So this is a collection of advanced open source command line tools. PT MySQL summary will work with any database. You just need a Bastion host, a server that has the Percona toolkit installed, and it can reach your endpoint. So if you have an endpoint that is RDS in AWS or Google Cloud SQL, you just need to connect PT MySQL summary, and it will work the same as it would even if you run on a local host and connect to MySQL on localhost. Additional tool that we use is PT Query Digest. So PT Query Digest is useful if you have a slow query log from a MySQL instance. You pass that slow query log to a PT Query Digest, and it will digest the query, and it will summarize. It will show you a report, for example, for the top 10 slowest query. With this command here, PT Query Digest will watch the process list on any database. You just connect PT Query Digest to the process list. Every 0.1 second, it will capture the process list. And this example, it will run 300 seconds as a daemon, and it will generate the same as if you would be analyzing the slow query log. PT Duplicate Key Checker will also work to a database as a service, showing you all the duplicate indexes, redundant indexes on a MySQL schema. PT Online Schema Change will work if it runs on a MySQL on localhost. PT Show Grants works, and there are other tools from the Percona toolkit that will also work. PT Summary will not work because that is not a tool that's related to MySQL, but it provides summary for the server that is executed. This is monitoring and observability in the cloud. AWS has this as performance insights. GCP has it as a query insights. All major clouds have this observability. but it's important that you already have this enabled. If you don't have it enabled, you will not be able to see these trends, all the metrics, what's going on your servers. As mentioned, this is free and it comes with 7 days retention. But even 7 days, it should give you enough information to check what are the trends and maybe even do root cause analysis. If you want to explore more and just monitor the trends on your servers for a longer time, you can pay for this service. And I think there are maybe more than 12 months of data that you can use with performance insights. If you don't want to pay, you can always go with something that's open source like PMM or other monitoring tools. For PMM, you will just need to have a server where PMM will run, and PMM also works connecting to database as a service endpoint. So you just need to have a connection between the two. It has rich graphs, it has a lot of dashboards and metrics, so you can monitor trends over time. Some of the common performance issues that we have identified over the experience of working with database as a service, and not just database as a service, but also with on-premise managed MySQL. These are the 3 categories going from left to right. What usually happens is that the most common reason for performance issues on a database system is that there are slow queries that are slowing down the system and using a lot of resources that probably are not supposed to do. Those are probably queries that has missing index or maybe inefficient index. So full table scan, something like that might be the first thing to look at before going with any other troubleshooting. So queries that join many tables, that the joins between the tables are not using index, or just query unnecessarily amount of data, or there is a high concurrency, there are many users that run queries, you provisioned your instance class with few CPU cores, maybe you don't have a lot of memory, then is the next thing to look after the workload. So first, it's always the workload, troubleshoot, slow queries, find if there is inefficiencies in indexes, and then look for what is the CPU load, do you have enough IOPS capacity, what is the disk speed, do you have enough memory. Those are the next things to look at, but before you go there, the first thing is the workload. And after that, if there is nothing else to tune, maybe you have some wrong setting on the database, maybe something that is limiting the database to use the resources. One case with database as a service, it might not be obvious, and the database as a service have the my.cnf pre-configured for you. But if you are running a MySQL with 100 gigabytes of memory and you just have a custom configuration for the buffer pool that is limiting the buffer pool to 8 gigabytes, then obviously there is not enough buffer pool, so you just have a memory that it's not assigned anywhere. But those are rare things and probably the last thing to check when dealing with performance issues. For scaling, typically there is horizontal and vertical scaling. In this example, I'm using horizontal as horizontal for scaling grids. With vertical scaling, is just growing the instance size, doubling the CPU, doubling the memory, going from small to large. With horizontal, it's just adding more resources to the existing pool of resources. For example, you have one instance in US West 1, there is a replica. You have deployed application in US West 2, and the application needs read scalability. You can just create a pool of resources in US West 2, and your application will scale horizontally. However, this is not a real horizontal scaling if you need sharding. Like with vertical scaling, there is a limit. You can only scale as much as the highest instance class, the highest instance size. So 1 terabyte memory or 128 CPU cores, and above that, there is not really anything that you can do. There is a limit on the vertical scaling. If you really need to scale horizontally and partition your data on multiple machines, partition your data horizontally across multiple servers, then you need to think about sharding. And sharding is something that you can do manually from your application. So if you have a microservices application, then you can create different set of databases, so every part of your microservices architecture can speak to its own database. And that's one way to shard. Other way to do that is use tools like Vitess, for example, that supports sharding natively. And in AWS for Aurora, for horizontal scaling of reads, you can do the Aurora auto-scaling feature, which Aurora can scale up to 15 replicas, and you just need to define a scaling policy with cooldown period, what is the target metric, whether it's CPU utilization, average connections, and then Aurora will take the rest. But the caveat is that you need to have at least one replica. So you have a writer, a reader, and then you can add more replicas in the auto-scaling group. For security, in the cloud, the security is a shared responsibility. So the cloud provides security guarantees that your hardware is secure, there are data centers that are secured, nobody can go in and plug off your hard drive. So there is security until there is a line between the provider and the customer, and the customer is then responsible for building their application secured. So for access, for example, database as a service will work with identity and access management, which is native in the cloud. And you can store your credentials in a secret manager, for example. So you don't need to expose secrets and share between your team. The applications can use the secrets manager feature in the cloud. It's always recommended to use the principle of least privilege and granting the minimal permissions. So if a user doesn't need any other privilege except that they will select on a single table, then just assign that. Don't give them insert and update and delete and everything else. Some of the databases that are often publicly exposed, the users don't even know why the database is publicly exposed. So unless necessary, don't expose the instance publicly on the internet. You can only limit the database access in a subnet that is on a VPC with the application, or you can create VPN or VPC peering, so it depends on the model and the infrastructure, but publicly exposed instance is definitely not recommended. There is encryption at rest by default. You can provide your own encryption keys, or you can use cloud-provided encryption keys. In GCP, every disk is encrypted at rest by default. There are some options for using multi-factor authentication, so use that everywhere where possible. And try to update and keep your database to the latest minor version, and keep track of the security vulnerabilities that there are at least quarterly released security vulnerability fixes. And in some cases, like in Aurora, there is the audit plugin configuration where you can actually use that as a free feature. So you just need to turn on some variables in Aurora. Now this is just an example, but prompt engineering is coming big. If you have a table and you need to do some testing from production to your local instance, you don't need to dump the data, demask the data, remove PII. You just get the table design, ask ChatGPT to generate 10,000 rows with random values, and it will do that for you with a single insert, and so it saves a lot of time. And for last, there are still some cloud-only features, especially with databases as a service. So Oracle is the biggest contributor in the MySQL open source version. They have their own Oracle Cloud, and they have their own managed database that is called HeatWave. So HeatWave has a lot of features that are just not there in the MySQL open source version. Like recently, they announced that there is a new MySQL hypergraph optimizer. They also have vector store and GenAI. They have autopilot for indexing, JavaScript store program support. So none of that is in the MySQL open source version. Everything is in their database as a service offering. Aurora, for example, has a feature for parallel query, and that you cannot see in the open source MySQL version. Or GCP also has the vector store, and they have features like adaptive caching layer, that there is a cache between the database and the application, so the application doesn't always go into cold hit. And I just copied this poll from Peter Zaitsev, who did this on LinkedIn. Do you consider HeatWave part of the MySQL ecosystem? To my surprise, 33% of the people don't know what is HeatWave. I answered yes on this. I consider HeatWave to be part of the MySQL ecosystem because on some conferences I heard that Oracle is doing all the innovation I mentioned at the beginning, so all the innovation goes to the cloud, so it's in HeatWave. But eventually there is a plan that they can release some of those features in the community version of MySQL. So for me, that's yes. But 43% of the respondents here said that they don't think it's part of the ecosystem. And with that, that's all for today. Any questions? Anyone with questions? Oh, okay. Thank you.
Oh, okay. That's very loud. Is it as loud for you as it is for me? Okay, okay. Okay. I'm not used to being this loud, so if I start whispering, just tell me. Okay. Should we get started soon? Okay. Cool. So hello, everyone. Thanks for sticking around until the very last talk of the day. Today, we're going to talk about MySQL, MySQL transactions, and we're going to talk about what can go wrong when we're facing multiple concurrent transactions and how we can, what we can do about it. So you could think of a simplistic database that would control concurrency issues by either getting all writers to wait for all readers to be done using the database, or the opposite. So it would get all readers to wait for all writers to be done using the database. And this is, in fact, what SQLite does. It's a very simple concurrency control strategy. For SQLite, it works well because in a lot of SQLite applications, there's only one user to the database. However, in a lot of enterprise databases like MySQL, this is likely not something you want, right? We usually want to have as much concurrency as we can get from our database. For example, if I sign up to your website and it needs to hit the database, then I don't want to have to wait until everyone else on the planet is done signing up or until some reporting query is done running in the background. So we usually want to maximize the concurrency. So MySQL and a lot of enterprise databases implement what's called weak isolation. So they do allow you to simulate, just like SQLite, that you're the only user in your database. But in a lot of scenarios, this can cause performance issues, and therefore MySQL implements what's called weak isolation as a trade-off for better performance. So in order to put examples on this, I want to start by a small demo here. I have two SQL sessions, one on the left and one on the right. For the purpose of this talk, we're going to pretend that these are two different people or two different processes that do not know about each other. So person on the left doesn't know what person on the right is doing and vice versa. So I have this little table here called heroes. It's very simple. It contains 3 rows, Batman, Robin, and Superman. They each have an amount of money, 25 and 35, and there's a comment column. For now, all it says is that Robin is just a kid. So I'm going to start a transaction on the left by saying begin. I could also say start transaction. There's synonyms in MySQL, but it's shorter, so I'm going to write begin like this. And just like this, I am in a transaction. So read my table again. And we can see I still have my 3 rows. While I'm doing this on the right, I'm going to give Robin a lot of money. So I'm going to say update heroes, set money equals 1,000, where name is Robin. And just to confirm that this went through, and we can in fact see that Robin now has $1,000. So nothing really complicated so far. Going back to my session on the left, remember these people do not have any knowledge of each other. So I'm going to read again from my table, and when I do this, you'll see that I'm still seeing Robin as having only $5. So I'm going to give you a piece of the puzzle right now. MySQL is trying to show me the data as it was at the start of my transaction. So having done this second select star from heroes, bear in mind, I do not know what's happening on the right. I'm going to act on it, and I'm going to make a note that Robin doesn't have a lot of money by updating his comment column. So I'm going to say update heroes, set comment equals not a lot of money, where name equals Robin. And there we go. And now if we select star from heroes again, we'll see that, well, we've just hit our first problem. we have just introduced corruption in our data because Robin now has $1,000 with a comment saying he has not a lot of money. Yeah, okay. Just for the recording, someone says, that's what my daughter always says. So maybe she doesn't know how to use her relational database well. So I'm going to commit this just to end the transaction. And here again, this is a silly example, 3 rows, and they're fictitious superheroes, but this could be serious consumer data or client data that we're dealing with. So I'm going to demonstrate a second effect here by issuing a begin. So this starts another transaction, and I'm going to do a select star from heroes once more. And I can see that, well, I can see the superheroes I have, so nothing special here. Now on the right, I'm going to take all of the money away from Batman. So I'm going to say update heroes set money to 0, where name is Batman. And just to confirm that this did indeed go through, we can see Batman now has $0. So going back to the left, I'm going to duplicate this and run it once again, and we can see Batman that apparently still has $20. So as I said, here's a piece of the puzzle. MySQL is trying to show us the data as it was at the start of my transaction. So what I'm going to do now is I'm going to do something a bit special. I'm going to issue a locking read. So there's a few ways you can lock things in MySQL, and one of them is by issuing a locking read. And what that does is it's going to lock everything that it scans. So the way you do this, or one of the ways we can do this, is by issuing a select star, but saying for share. And this is going to say select the data, but also place locks on it. So when we do this, we now see Batman as having $0. So here we saw 20, and here we now see 0. Now this can be confusing because we're seeing 2 different versions of the same data in the same transaction. Now what's going to happen if I go back to regular read here, select star from heroes, and run this again, I now see 20 again. So this can be confusing or a bit surprising, and it's important to be able to anticipate and control these effects when we're using MySQL. So commit this second transaction, and now I'm going to demonstrate a third effect. So begin, just to start a third transaction. I'm going to select star everything from my heroes table once again. And we'll see that I have my three rows. And what I'm going to do this time is on the right, I'm going to insert a 4th row. I'm going to say insert into heroes, values, and who's a good hero? Can I get some audience participation here? Captain America. Captain America, who has $0 and no comment. Okay, so just to confirm that this indeed did go through, if we select star, we see that I now have 4 superheroes in my table. So on the left, what I'm going to do this time is I'm going to pretend I'm going to copy this data. So I'm going to copy everything that I have in my heroes table in another table that I already have prepared that's called heroes2. Its structure is identical, but it's completely empty. So let's just confirm this. Select star from heroes2 here, and you can see my table is empty. The columns are exactly the same. So I'm going to say insert into heroes2. Select star from heroes. So this should copy the 3 rows that I saw in my heroes table. And, oh, excuse me, I missed a step here. So pretend I didn't run this insert yet. And I'm going to say select star from heroes again. So what we see is that we still see these 3 rows. We don't see the 4 rows yet because MySQL is showing us the data as it was at the start of my transaction. So I've already ran this this insert into, and if we look into our heroes2 table here, what we'll see is that we have 4 rows in our heroes2 table. So we went from 3 rows that we could see, did a select star on that thing, and somehow went to 4 rows in our heroes2 table. So I'm going to commit this here to end the transaction. And if these were confusing or surprising to you, then this is what this talk is about. We're going to put words on everything that we've seen. We're going to explain all of it, and by the end of this talk, you'll be able to control these concurrency issues, identify them, prevent them, and even allow some of them as a trade-off for better performance. So let's go back to my slides here. Today, what we're going to see, first we're going to make sure that we're all on the same page by defining what a transaction is. Then we're going to look at a few implementation characteristics of InnoDB. And by the way, today I'm going to talk about MySQL, but when I say MySQL, what I really mean is MySQL using the default storage engine InnoDB. So there's a few pluggable storage engines. Not all of them have this transactional behavior. So if you use other transaction storage engines such as Blackhole or Archive or even the ancient MyISAM, then this won't apply. But it does apply if you're using InnoDB, which is kind of the industry standard for MySQL nowadays. If you're not so sure which storage engine you're using, then you can always issue a show create table statement, and that's going to tell you which storage engine backs your table. So we're going to look at what a lock is in MySQL or InnoDB, and then we're going to look at 3 different types of read that we can do in MySQL. So when we issue a select statement, there's actually 3 different types of things that can happen. After seeing this, we're going to look at how InnoDB deals with concurrency in a non-locking way through a strategy called multi-version concurrency control, or MVCC for short. And then that's going to be the real fun part. We're going to see how MySQL applies the SQL standards. So we're going to see the 3 types of read phenomena defined by the SQL standard. We're going to look at them, play around with them a little bit, just so we get a feel for them. And then finally, we're going to see how we can control these phenomena by using the 4 transaction isolation levels defined in the SQL standard. So let's start with by defining what a transaction is. A transaction, this is my definition, but if you look anywhere, you'll find pretty much the same thing. It's a sequence of statements that is atomic with regards to persistence and that can be isolated from other transactions. There's 2 parts to this definition. The first one is that it's atomic with regards to persistence. And what this means is that by the end of a transaction, either all of the statements in a transaction will be persisted to the database or none of them. You'll never run into a situation where someone trips on the power cord in the middle of your transaction and then only half the statements of your transaction get persisted to your database. That's the first part of the definition. The second part is that a transaction can be isolated from other transactions. And this is the part that's going to be of interest to us. So you've already seen some of the effects that can occur when we have weak isolation in transactions. So we can kind of see other things from other ongoing transactions. And finally, in MySQL, you saw that on the left, I was always controlling transactions explicitly by issuing begin, or I could have said start transaction, they're equivalent, and commit, I could have also have said rollback. But in MySQL, even if you don't specify transactions explicitly, everything always runs inside a transaction. By default, there's a mode called auto commit, and when auto commit is enabled, which is by default, everything that you do, every statement will always run inside its own transaction. So if you issue a select star from something without having said begin or commit, then before that select star, it will open a transaction, and at the end, it will implicitly commit the transaction. So it's good to know how transactions work because everything always runs inside a transaction. Now let's discuss what a lock is in InnoDB. A lock is an access right to a resource, and that resource can be of 3 types. It can be a table, can be a row, or it can be a row plus its preceding gap. So InnoDB is able to lock gaps between rows. In MySQL, all logs are always kept until the very end of a transaction. So all of the logs you take during a transaction will kind of pile up until you either commit or roll back to end your transaction. And logging is a pretty complicated subject in MySQL and InnoDB, but for the purpose of this talk, it's sufficient to know that a log prevents concurrent modifications of a resource. So if I have a log on something or on a row, no one can update that row while I have the log. That is until the end of my transaction. And if I have a log on a row plus its preceding gap, then no one can either update the row or insert a row into that gap until I end my transaction and release the log. There's a few statements in MySQL that always take logs. For example, everything that you update, insert, or delete will get logged until the end of your transaction. All rows that are scanned in update or delete statements will get logged. And all rows that are scanned in the select part of an insert into select, if you're in repeatable read or higher, will get logged. I know that this is a lot of theory, and if you ever need to refresh your memory, then MySQL has a really good documentation page called, if I remember correctly, it's logs set by different SQL statements or something like that. It goes through every single case where MySQL takes logs. And finally, if you want to control logging explicitly, you can also do logging reads, for example, by doing select star for share or select for update, like I did in my demo. Now, when you issue a select statement in MySQL, there's actually 3 different types of reads that can happen. The first is what you might think of as a plain select statement. InnoDB actually calls it a consistent non-locking read. And there's 2 parts to this name. The first one, non-locking, obviously means that it doesn't take any locks. And the second one, consistent, means that the data that is returned by a single read will always belong to a single point in time. So if you issue a select statement that takes an hour to run because you're scanning a huge table, then all of the rows that you get back, even if there was concurrent activity on your table, will belong to instant 0. We'll see in just a second how MySQL does that. So consistent non-locking reads will always give you data from a single point in time. And if you remember from my demo, a couple of times I said MySQL is trying to show me the data as it was at the start of my transaction. Well, that was an instance of a consistent non-locking read. And this might still be a bit fuzzy, but we'll play around with it and we'll see how it works. And I'm sure you'll understand all of it, or all of this will make sense by the end of my talk. One exception to this one snapshot rule is that consistent non-locking reads, or any reads in MySQL, will always show you the results of earlier inserts, updates, or deletes that belong to your transaction. And only with this, how long has it been? 17 minutes. We already have a key to the first effect that we saw in our demo. You might not have seen it, but when we updated Robin by giving him $1,000, and then my transaction on the left updated his comment by saying not a lot of money, the reason that I saw, when I then issued a select statement, the reason that I saw 1,000 and not a lot of money, even though my previous select statements were still showing me $5, is that MySQL started considering that the row belonged to my transaction. So I updated it myself. It said, okay, you updated it. Well, I'm going to show you the truth now, and I'm not going to try and use a snapshot. So then it started showing me, well, the actual latest committed version of the data. Second type of read is a locking read. A locking read obviously takes locks, so it prevents concurrent modification to a resource, and unlike consistent non-locking reads, they will always show you the latest committed version of a row. This will make a lot of sense, I'm hoping, in just an instant when we look at MVCC, and we'll see the difference between these two strategies that MySQL uses to read data. The third type of read there's no real name for it in the documentation, and it's not very clear the way it's said in the documentation, but if you're in read uncommitted, your reads will be inconsistent. So there is, if you have a select statement that runs for 1 hour, then the first row that is scanned will be returned to you and belong to instance 0, and the last row that is scanned will belong to instance 0 plus 1 hour. We'll play around with this and see a few examples in just a couple of minutes. But now I want to show you how this all connects and into a coherent strategy. So how consistent non-locking reads and locking reads interact in something called multi-version concurrency control. And that's the strategy used by InnoDB to control concurrency without taking any locks. And instead of talking through my slides here, I want to show you, I want to draw something here. And okay, looks like we're good. I want to illustrate what happened when I went from Batman having $20 to Batman having $0. So what happened when I did this? Let's pretend that this is our MySQL table here. Let's call it H for heroes. I had 3 rows in there. I had Robin, I had Batman, and I had Superman. And Batman, if you remember, here, B for Batman, and Robin, and S for Superman. And if you remember correctly, Batman had $20 at the start. And what happened when I updated Batman and said he now has $0 is that MySQL went right ahead and overwrote the data that it was in my table, even before the transaction committed, and it wrote the new version in here. In addition to this, it also left some kinds of breadcrumbs. It left some information in a specific data structure called an undo log that lives somewhere else, not in my table. It lives in an undo table space. So here I'm going to say U for undo table space, and it created an undo log record that contained the old version of the row, of the information. So effectively, it contained the number 20. And this is used for if the transaction ever has to roll back, or it's also used for MVCC. And now let's look at how this works. So, I forgot one important bit. When MySQL overrode my 20 with my 0 here, in addition to this, in addition to leaving information in my undo logs, it left some information in a couple of hidden columns that are kept by InnoDB. And the first one is the identifier of the latest transaction that modified this row. So it left its identifier in there and said, I did this. So let's pretend that the ID of the transaction was the number 7. Who knows? Could have been. And it also left something else. It left a pointer to this undo log that contained the number 20. So I'm going to call this P and represent it with a circle. So what happened when I needed to read this row and MySQL showed me the number 20, so the old version of the row is, I'm going to change colors here, is that I issued a consistent non-locking read here. I'm going to write C for consistent non-locking read. And the way this works is that MySQL started scanning my table, and for each of the rows, it looked at the transaction identifier. If it saw that the transaction belonged to an instant in time earlier than the snapshot it wanted to show me, then it knew that it was okay to go ahead and show me the information that was right in my table. However, when it got to this row here that said Batman and 0, it looked at the transaction identifier and realized that the transaction belonged to a point in time after the snapshot it wanted to show me. So what it did is it followed this pointer into the undo table space and use this information to do what I like to think of as a Control-Z. If you use Microsoft Word and you do a bunch of edits to your document, what Microsoft Word does in the background is it keeps track of all of your modifications, and whenever you do a Control-Z, it pops one off the stack and it goes back through the previous versions of your document. So that's what happened here. There could also have been multiple concurrent updates to this row, in which case MySQL would have had to work harder to reconstruct the previous versions, so it would have had to do more Control-Zs. I will take them at the end just for time, but I'll be more than happy to answer them. Yeah, okay, so let's complete this. In a consistent non-locking read started by scanning this row. It saw that the transaction was in the past, so it showed me this. I scanned this row. It saw that the transaction was after the snapshot it wanted to show me, so it used the undo logs to reconstruct the previous version of the row. And when it got to here, it just simply, same as before, returned this row. Now, the reason why this is important, or why this resulted in so many surprising effects earlier in our demo, is that I mixed this with locking reads, or anything that takes locks. Here I'm going to write L in red. I think that this is red. And the way that this works is kind of similar, but not really. So for each row that it scans, a locking read will place a lock here. But when it gets to rows that have to be reconstructed with MVCC, it's still going to place a lock. And what it's going to return to me or to the user is whatever has been locked. And here you can see that my L is in here. It's right in my table. It's not in this undo table space. So in other words, MySQL locks the row and returns whatever data is in it. And what data is in my row is always the latest committed version. So locking reads do not use this here. They cannot, because they need to lock something that actually exists. And this information is not a row. It's something that needs to be reconstructed algorithmically. So just to complete our diagram here, locking read completed the scan, placed a lock here, and returned this here. So the reason why we saw Batman going from 0 to 20, and the reason why we saw 3 rows going to 4 is actually this difference here, the difference between consistent non-locking reads and locking reads. One uses MVCC, the other doesn't, and always returns the latest committed version of your data. So now comes the fun part. Now that we have all of this theory down, we can kind of start playing around with this. MySQL, how do you say this in English, does something with the SQL standard, implements the SQL standard, and the transactional part of the standard was defined in SQL 92, so already 33 years ago. And they defined 3 types of read phenomena that describe things that can go wrong or that can happen when you have concurrent transactions working on the same data. The first one is non-repeatable reads. A non-repeatable read is when a transaction reads a row, then reads it again, but the second time it reads it, it finds that the data was either modified, or deleted. This is what happened when, for example, Batman went from $0 to $20 and then back to 0 again, or the other way around, I forget. And it's also what happened when Robin, I saw $5, I updated it, and then I saw $1,000. So this can also be thought of as a non-repeatable read. Phantom read is when a transaction reads a set of rows, and then the second time that it reads the same set of rows, it finds that there are now more rows. So when I had 3 rows going to 4 rows, can be thought of as a phantom read. Finally, the third read phenomenon is dirty read. A dirty read is simply when you read data that was modified or inserted or affected by other transactions, and those other transactions have not yet committed. Most likely something you don't want from a production database, because if you read something that hasn't been committed yet, it means that there's always a chance that the data will be eventually rolled back, and so that the data you get will never have been persisted to the database. So effectively, if you get dirty reads, it means that the data you're reading is not reliable. Now, MySQL allows you to control these read phenomena and kind of find your sweet spot on a slider that goes from strongest isolation and lowest performance all the way to strongest or best performance and weakest isolation. And the way you do this is with transaction isolation levels. These levels can be set globally by session or by transaction. We'll see how to do this. And most importantly, they're implemented with MVCC and locking. And this is why we spend so much energy discussing MVCC and locking. It's because it's actually how MySQL controls concurrency and how it lets you control how much it's doing to prevent read phenomena. So there's 4 levels that are defined in the SQL standard. You might remember them from computer science school or from tutorials or from anything. They're all over the place. They're serializable, repeatable read, read committed, and read uncommitted. That's from strongest isolation to weakest isolation. But for the purpose of this talk, we're going to look at them in an order that will make sense for us. So the first one I want to discuss with you is repeatable read. Oh, excuse me, I see a phone went up. Tell me when you're done. Are you good? Okay, cool. So repeatable read is actually what we've been using all along, because it's the default isolation level for MySQL. So if you use a plain MySQL installation and you've never configured anything on it, you're using repeatable read. Now, repeatable read affects 2 things, MVCC and locking. For MVCC, what it does is that the first select from an InnoDB table in a transaction will establish a snapshot that your whole transaction will use. So in all of my demos where MySQL was always trying to show me the data that as it was at the beginning of my transaction, the reason was that I was in repeatable read, the default, and that my first select established the snapshot that all of my transaction was using. As we saw, this strategy does not apply to locking reads, and it can also be more resource intensive, because for the duration of a transaction, MySQL is going to have to keep undue logs for everything that happens in your database in case your transaction ever wants to read something from that point in time. So if you have longer running transactions, then depending on your use case, it could be beneficial to performance to use something else that does not have this long running snapshot that belongs to your whole transaction. And we'll see how to get to that in a second. In terms of locking, what repeatable read does is it does gap locking. So it's actually able to lock the absence of something. So if you ever see something like insert into where not exists, that is, if you ever want to enforce the invariant that nothing gets inserted into some table or some gap, then it is likely that you need repeatable read to enforce this. So in terms of read phenomena, what repeatable read does is that you won't get non-repeatable reads or phantom reads, and there's an asterisk here. The asterisk means except for this funny interaction between MVCC and locking reads, and except if MySQL starts considering that the row belongs to your transaction and now shows you the latest committed version. So kind of a tricky isolation level. You won't get, however, dirty reads. This is guaranteed, and your read consistency will be transaction-wide. Now let's go back to my IDE and play around with this for a while. Oops, wrong window. Now we can already look at some solutions to the effects that we saw earlier. If we look at, this first one, when I updated Robin's comment, and I was kind of surprised that I saw that I had introduced data corruption into my data, then there's two things I could have done. If you ever see that in a transaction you need something to remain true for the duration of your transaction, then you can use a locking read for this. So for example, I said select star from heroes, and the fact that Robin had $5 was important to my application, and I needed it to remain true. Then I could have performed a locking read on that row, and then for the duration of my transaction, no one else would have been able to modify it. The second thing I could have done kind of boils down to the same, but if I had, instead of update heroes set comment where name is Robin, here, let me format this better. If I had added my precondition in here and money equals 5, we saw that the rows scanned in an update statement are locked. So this comes down to the same thing. MySQL would have placed a lock on Robin having $5, and I would not have had this non-repeatable read. So that's two ways we can solve this. Then for this third one here, when I had 3 rows going to 4, what I could have done, if, for example, the fact that there were only 3 rows was very important to me, then I could have added a where in this insert into statement, or I could have performed a locking read in here for share, and that way no one would have been able to add a 4th row. Speaking of this, let's demonstrate this in a little more detail. I'm going to start a transaction here, begin, and I'm going to say select star from heroes for share. And since I'm in repeatable read, now not only the rows will be locked, but also the gaps between the rows. So if I go on my session on the right and I try to insert something else, you'll see that it's not going to be able to go through. It's going to have to wait until my transaction commits and therefore releases its locks. So that's repeatable read. Now, going one level down, read committed does 2 things. In terms of MVCC, every consistent read will get its own snapshot, so you won't have this one snapshot to rule them all that starts at the beginning of your transaction. And that means that you're also potentially going to have less use of undo logs. In terms of locking, you're not going to get gap locking in read committed. So if I go back to my IDE and run the same example, but one level down, so I'm going to change my isolation level by saying set session transaction isolation level, read committed, like this. I am now in read committed. If I omit the session, then this statement will only have an effect on my next transaction. So having set session here affects my whole session. If I copy and paste this, begin a transaction, select star for share, and insert my row here, you're going to see that it goes right through because I do not have any locks on the gaps. And commit. So in terms of read phenomena, read committed, you will get non-repeatable reads, you will get phantom reads, but you will not get dirty reads, and your read consistency will be statement-wide. Now, here's the weirdest level of all, read uncommitted. Read uncommitted lets you see uncommitted data from other transactions. On top of this, it also does not use MVCC at all, which can lead to really surprising results. Now, I hope I'm not making you dizzy, but let me go back to my IDE here. And what I'm going to do, I have this table here called T, and all it contains is five rows, 1, 2, 3, 4, 5. And what I'm going to do is I'm going to change my isolation level to read uncommitted, set session, transaction isolation level, read uncommitted. I am now in read uncommitted, and I am going to slow down artificially this scan. So I'm going to say select star, comma, sleep, 1. And what this is going to do is the exact same thing, except it's going to take 5 seconds. And that's going to give me time to completely wreck my table. So on the right, I'm going to say update t set a equals 1,000. This is just going to overwrite everything to 1,000. And I'm going to do this concurrently to my scan on the left. So I'm going to start this and quickly go to the right and run this here. And what you'll see is that we get half of the before result and half of the after result, meaning read uncommitted even breaks statement atomicity. So you're able to see partial results from one SQL statement. Going back to my slides, my recommendation to you is to only use read uncommitted if the explicit goal of your transaction is to read uncommitted data. I have one good example of this. If you're ever working with JPA or something that hides or abstracts away what's happening at the SQL level, and you have an application or an integration test that's running a transaction and you're not quite sure what's happening in your database while your transaction is running, then if you try and, let's say, place a breakpoint, halt your test, and log into your database via an SQL console, you're not going to be able to see what your database is doing because it's inside a transaction, and by default, repeatable read will hide dirty reads from you. So the way to do this is simply to turn down your isolation level to read uncommitted, and then you'll be able to see what your application is doing and maybe troubleshoot your tests a little easier, or a little more easily. So in terms of read phenomena, you just get everything, non-repeatable reads, phantom reads, dirty reads, and absolutely no read consistency. Now this last isolation level, serializable, is by far the easiest one. What it does is MySQL simply takes just enough logs to give you the illusion that you are the only user of your database. So if you remember at the beginning, I said MySQL is able to emulate or simulate that you are the only user of your database. Well, that's if you use the serializable isolation level. However, it comes with a performance trade-off. Not only will everything that you read have to be logged, but you'll also run into contention issues much sooner. If you're ever in that situation where you're having issues with contention, there's two things you can do: no wait or skip logged. I'm looking at my time and I'm running out of time, so all I'm going to say is if this interests you, then you can find more details about it in the documentation. But you can see on the bottom, you get absolutely no read phenomena, and your read consistency is transaction-wide. Now, in conclusion, these are the read isolation levels implemented by MySQL. You can see that by far the trickiest isolation level is repeatable read. A little over a year ago, Jepson, the Distributed System Research and Database Testing Group, published a pretty scathing analysis, unfortunately, of MySQL transaction isolation. And they pointed out that this repeatable read isolation level does not correspond to any other database or any known consistency level in the literature. A few months after this, MariaDB, which is a fork of MySQL and which also uses their own fork of InnoDB, they patched their version of InnoDB so that now you can start a MariaDB database with a database flag. And what it's going to do is that if it sees that you're trying to log something that was modified after your snapshot was established, then it will simply return an error. So that's a much easier user experience. What else did I want to say about this? Oh, you might have noticed that I was a bit hand-wavy in my identification of these read phenomena. And the reason is that when they were released in '92, it didn't take long for researchers and academics to find issues with them. And it turns out that they're both imprecise and incomplete. However, they're still used in the industry. It's a bit unfortunate. If you want to know more about different formalisms that academics and researchers came up with that are much more precise, You can look at this here, Jepson.io. It's the company I mentioned earlier. They have a really beautiful or beautifully made summary of everything that's in the academic literature. It's very dense. It's a lot harder to understand than just this. If you're only using MySQL, then MVCC and locking is a good mental model to deal with transactions. But if you ever want to compare this with what other databases are using, then you need more precise formalisms like the ones you find in the research literature. So in conclusion, I hope that I was able to give you some ideas on how to better work with concurrent transactions and ultimately prevent data corruption and keep your businesses thriving. Thank you very much. Now, I can take questions if you have any. Yes. Okay, so the question was, can I go back to my Miro board? Yes. Yeah. This is an undo table space. It's just another area of disk, another area of your database. The actual data structures that it contained are fairly complex. I'm sorry, what was your question? Yes. So I want to be very careful here because what happens in this bit of the database is very complicated, and I spent hours and hours really looking at the source code trying to make sense out of it. So the changes to one row are stored in a sort of a linked list. So if some transaction needs to go back a few versions, then it has to walk that linked list. There is... Yeah, that's all I'm going to say because the rest is not something I'm hugely familiar with. Anything else? Yes, I do. Yeah, so there's, without saying too much, I used to work on a team that used Aurora, so not MySQL. It's wire compatible. I'm sure other teams use the actual MySQL. Awesome. Oh. Yes, so InnoDB does something called next key locking. So it's able to place a lock on a row or on a row plus its preceding gap. So you might see that there's something's off here, something's missing, because if you lock all three rows in a table, then what happens? Like over that, if you're only locking the preceding gaps, there's a thing called supremum records that are not user visible. They're only internal markers, and they're kind of dummy rows that will get next key locked, so that your database is able to lock the upper end of your table. Yeah, so if you have a table containing 3 rows and you're only doing next key locking, meaning you're only locking a row plus its preceding gaps, you'll see that the first one will lock the first row and everything before. The second one will lock the second and down to the first one. The third will lock down to the third one. And then what do you do after this? What do you do from if someone adds a fourth row in that gap? So that's kind of an implementation detail, but it works. Yes. Yes. Yeah, so I'm not very familiar with the output of show engine InnoDB status. You're saying that you're able to see the number of gap locks? Yeah, so if it's something that you need for your business logic, then you need them. If you want to avoid contention as much as possible, then you can try and look at the transactions that take gap locks that are being problematic and say, can I afford having phantom reads in this gap? And then if the answer is yes, then you can use isolation levels as a trade-off between performance and isolation. Yeah, there's a few other pluggable storage engines. One of them is Black Hole, it just does nothing. One of them is Archive. I'm not very familiar with it. But basically, if you use anything else than InnoDB, then this does not apply. Yes, yeah, let me show you. So I have this table T here, show create table T, and I have, here it says engine InnoDB. I'm not sure. You said show default engines? Okay, cool. So there's a way you can also look at your default storage engines. Yes, InnoDB is now the default storage engine. Okay, so you still use MyISAM? Yes, yeah, MyISAM is mostly being replaced by InnoDB. Okay, well, thank you, everyone. Have a good evening.